Hi, Melanie. Oh, you're muted. It's great to be here. Nice to be here
Yeah,
with
I'm
you.
excited to be here today too. I'm Melanie Plageman. I'm a Postgres committer and contributor working at Microsoft.
And I'm Pino de Candia. I'm an engineering manager at Microsoft. And I'm delighted to be here with everyone. I want to welcome everyone, wherever you're joining from. I'm in New Orleans. Beautiful sunny day, perfect day for this conference. Very exciting. We've got a great program for you today. In fact, this is live stream 3. We're having 4 live streams during the conference. They're each 5.5 to 6 hours long. The first live stream happened about 24 hours ago. The second live stream, which was done in EMEA time zone, just finished about 3 hours ago. And in about 9 hours from now, live stream 4 will be starting. So those are the 4 live streams. And you can find them on aka.ms/Posette schedule. The live streams are hosted by these great people. The arrows are highlighting Melanie and me. We're hosting this live stream 3. Tomorrow, you'll see Yelte and Boris if you tune in. Sorry, I said tomorrow. No, sorry, in about 9 hours in live stream 4.
Tomorrow for Europe or for EMEA, right? Or no,
Right.
wait, today, something like that.
I think you're right. It's tomorrow for Europe.
Hard.
And please do go back and watch live streams 1 and 2 that were hosted by Claire, KK, and Floor. And I want to remind everyone that Microsoft is brought to you by the Postgres team at Microsoft, and I want to thank the leadership of Microsoft for supporting the conference.
One of the great things about this conference is that it's virtual, and so anybody can access it who has an internet connection. Doing conference organizing, one of the things that we struggle with a lot is how to make it accessible for an in-person conference for everyone to be there, and including speakers. So I think that having such a high quality virtual conference like this is really important for the community. And one of the things it can do also is for first-time speakers, it gives them a lower barrier to entry. They can do their first talk, and also for experienced speakers who maybe can't travel for different reasons. So I think it's awesome that we have this.
I love it. It's all digital from the start. We have opportunities to do things that might not be able to do. On the other hand, it's nice to have a balance. We have so many great on-site presential conferences in Postgres, and this virtual one is a great add to the mix.
Yeah, totally. So during the event, just like any in-person conference, we adhere to a code of conduct. So that applies to the Discord channel, any way that you would communicate during this conference to us as hosts, during the live stream, during the talks. And so that has your basic code of conduct things, but just kind of be respectful. There's no bad questions. Just be supportive and positive. This is supposed to be an event for all of us to learn and grow and to highlight the amazing things that Postgres can do.
There are over the conversations have been great. There are over 200 people in the Discord channel right now. It's a really fun place to be.
And the theme of sort of making it as inclusive and accessible as possible, there is also live captioning, and that's in a bunch of different languages. So if you, if English is not your first language, or if you just would like to see captioning for the talks, that's one of the awesome things about this conference is that they're there.
Right, we had 14, and on request yesterday, a 15th language was added. So the captions will be available in other languages in recordings that are posted after the event, immediately after the event. We've got Chinese, Czech, Dutch, French, German, Italian, Japanese, Korean, Polish, Portuguese, Russian, Spanish, Turkish, and Ukrainian.
That's awesome. So many languages.
Now, if you're live posting the event, we'd like to ask you, please, to use hashtag PosetteConf in your posts. Some folks have been posting with hashtag Posette. If we all converge on hashtag PosetteConf, it'll generate more momentum and visibility. So we appreciate that. Wanted to let everyone know that you can follow us on X, on Mastodon, and on Threads. We're in all those places. And really special, this is a really special slide for all of us. I want to thank all of our speakers. We have 44 speakers this year and 42 talks. And our speakers range from Postgres committers, contributors, ecosystem tools and extensions developers. We have users, we have customers of Azure, all sorts.
We really have so many perspectives, and app developers too, which I think is a demographic that we're trying to hear more from them. Their use cases are different, and so I'm excited that we have so many different perspectives. And it's a lot of work as a speaker to make a talk, so we really appreciate that they all took the time to create this amazing content.
Yeah, thank you to all the speakers. And I'd like to thank our selection team. There were 184 submissions to the selection team. It takes a long time to go through all those talks. I think Melanie will have more to say about the difficulty of the process, but I'm just very impressed. I mean, going through that many talks, finding a good balance of topics, and deciding what to focus on, see what the trends are. I'll just say there's a blog. It's highlighted at the bottom of the screen about how the talk selection process went, and it was very exciting to read about.
Yeah, and I'll just say that we spent time on every talk. I mean, it took multiple days, a full day of work. So like, we really read not just the talk proposal, but your speaker bio. So if you're thinking about submitting a talk, like the talk selection team really looks at both any links that you include to additional content, the abstract, and your bio. And we want to create the best experience and feature the best content. So it really helps if you explain, what why you're an expert in this area. And I think there's also great content out there about how to, and I think Claire has in the past created content on how to decide what to talk about and preparing for, submitting an abstract and things like that. So we really want to make this an environment where people get the opportunity to speak that maybe haven't before, and people that are experienced speakers can, try out and create content that is maybe different from what you see at other Postgres conferences and explores interesting topics. And we really do take the time in the talk selection team to get into it and really, read every proposal.
So Melanie, I want to thank you for being on the talk selection team, and I want to thank by name Alicia Kucharczyk, Claire Giordano, and Daniel Gustafsson. Thank you for all your hard work. Next, I'd like to thank the organizing team, Teresa Giacomini, Aaron Wislang, Ariana Padilla Acosta, and Aaron Bazak. Organizing the conference is a huge amount of work. The organizers are still hard at work, and behind the scenes, still at work right now. For months, actually, this effort started pretty much right after after last year's conference. I also want to take the opportunity to call out our producer Monique, who is working right now with us and supporting us so well. So thank you, Monique. Now, I'd like to remind everyone that you can join the virtual hallway track on Discord. So if you go to aka.ms/open-source-discord, you'll have a quick link to get into Discord, get an invite, and you can go to the hashtag PosetteConf channel. There are over 200 people there right now. People are really friendly. All sorts of topics come up during the course of the live stream. It's really fun. And the special thing about this conference is the talks are pre-recorded so that our speakers are live in the channel, and every single one of our speakers has committed to being in the channel, during their presentation, and often they hang around beyond that, and they take questions about their talk and about other topics.
This is like we've managed to clone them, right, by having the pre-recorded talk, and then during it they can answer your questions, while you're giving the talk. I know in the past when I've been a speaker and then for a virtual conference and there's a simultaneous live chat, it's almost impossible to focus on your slides and actually answer people's questions. So this is kind of a cool trick where you actually, the speaker will be able to answer your questions during the talk.
Right. All right.
And we also have some amazing swag that Teresa and the team has made available. So I think there's some codes that are in either in the Discord channel for being able to claim your swag. There's sticker packs, and I think there's a few socks. I don't know if there's any still available, but if you use one of the codes from the Discord channel, you should be able to claim your swag and go to aka.ms/Posette swag.
I generally find that this community gets really excited about swag, and it's fun. It's just a fun thing.
It is, definitely.
So we want to say that we have Azure Azure engineers and employees and customers on in the conference as well. And so there's a cloud skills challenge. Actually, there are two that you can do on Microsoft Learn. If you complete them, you can complete one or both by June 24. You're entered in a lottery to win one of these hoodies or T-shirts. And the link is at the bottom to register, aka.ms/Posette CSC, Cloud Skills Challenge. Now, if you want to sort of see a blog about this conference, there's this ultimate guide. It's linked over here, aka.ms/Posette guide. This is a long article that has everything you might want to know about this conference. For one thing, where did the name come from? How did the talk selection process go? It groups the talks as well. So, for example, we invited 4 keynote speakers, and then there were 38 selected talks. Melanie, do you want to say a little bit more about the groupings?
Yeah, so I think we'll cover a little bit today the different what talks fall under which groups, but as part of the talk selection process, we really tried to make sure that we, had multiple different areas. Of course, AI is really hot right now, so we got so many AI proposals. We wanted to make sure that we really emphasized and demonstrated and had content about how you can leverage the power of AI to and Postgres together. Then we have talks about Postgres core, which, things like internals, and that's always really interesting. As a Postgres hacker, that's really the only content that I could create. So I'm always super excited to hear other people's content like that. But then it's, for me, when I attend conferences, I'm always looking to the non-core Postgres content because I can learn a lot from that. And so I'm excited about the ecosystem talks. Postgres has such a large ecosystem because it's so extensible of extensions, and then all the different applications and drivers and things that make it possible to use Postgres for so many use cases. And then we have a lot of Azure Postgres talks that will we have Azure customers that are like, how can I really get the most out of Postgres on Azure? So we're excited to have some of those. And then we have community talks. So the Postgres community, it's not just code. There's so many parts to being an open source community. So I'm excited that we have some talks about the community aspect. And then we have 4 keynotes. And if you go to the next slide, we have a little preview of each of them. So today, Sarah is going to give the keynote about open source and Kubernetes and some of the principles and values there. And then Charles yesterday in Livestream 1 gave a talk about our Postgres open source efforts at Microsoft. Regina in the what was the middle of the night for me, but on Livestream 2 in EMEA. Regina is amazing, giving a talk about PostGIS and the open source Postgres geospatial community. And then in Livestream 4, which hasn't happened yet, Thomas Monroe, my teammate, is going to talk about a walking tour of Postgres. Thomas is such an expert in the history of Postgres and can really just give you that, it's this amazing project that's been going on for so long. And so having that background and then diving into how the community works today it's really helpful to have that perspective.
We're certainly grateful to have all these great keynote speakers. So if you have feedback, we have links so that you can give feedback both for individual talks and for the event as a whole. Please do remember that when you're giving feedback for talks, it's one survey. Fill out the survey once for each talk. There are only about 4 questions, so you can do it pretty quickly. And just refresh the link, and you can submit feedback for other talks. You can do that at any time until Tuesday, 18th of June, end of day.
And I know as a speaker, I really value talk feedback. So I really recommend taking the time to give feedback on the talks. And it also helps to the talk selection committee to know what talks and what speakers you want to hear more for the next year. So it's really important.
That's great. I've actually heard several times people say it's literally say this. It's a gift to the speaker to give feedback, and that if you appreciate the talk, that's one way you can show it by giving a lot of feedback. So
cool. So we have a lot, as we've sort of said already, we have a lot of exciting content today, and so we just want to give you a preview of what you're about to see, basically.
We'll roll the trailer.
Hi, I'm Sarah Novotny, and I'm a longtime open source community contributor. I've worked in projects and communities like MySQL, Nginx, and Kubernetes, to name a few. And today I'm going to talk about Kubernetes and the different things that I have learned and loved from that project.
2 years ago, I gave a talk at CitusCon called Explain the Postgres Query Optimizer. And today I'm giving the follow-up to that talk, building on the basics of Explain the Query Optimizer, talking about all the other things that the optimizer does that I didn't get a chance to talk about 2 years ago. So I'm looking forward to this talk, and I hope you enjoy it too.
I help customers migrating their workloads to Azure, and I've been working with many customers around the world across different industries in complex PostgreSQL implementations, and I've been helping them in resolving the performance and scalability issues.
Hello, I am Pamela Fox, and I'm talking about pgvector for Python developers. pgvector is a great extension that you can use in order to store vectors in your database and then do distance operations on them. It's incredibly useful if you're doing any sort of similarity search, especially for generative AI applications like retrieval augmented generation, in order to search and chat with items in your database. So come to my session to learn more about pgvector for Postgres and Python.
We are here today to walk you through a presentation on PostgreSQL physical replication, the internals of this, recent developments, and what sort of future work can be done around physical replication.
Hello, my name is Grant Fritchey. Today I'm going to talk to you about using Query Store to understand performance inside your PostgreSQL database. This is really important because unless you know what's happening inside your database and you know how your queries are behaving, tuning those queries and getting them to run fast is going to be really difficult. But Query Store inside of your Azure Postgres database will absolutely help you get it done. Come to the session, find out how.
Hello, my name is Taylor. I'm here to talk to you about Postgres, specifically task queues in Postgres, specifically how to implement and use them for great benefit so that you do not have to use something like PubSub or Airflow or Kafka, whatever those other things are. You could just use Postgres. It's very nice. So yeah, let's get into it.
My name is Denzil Ribeiro. I'm a principal product manager at Microsoft working on the Postgres service. And today I'm going to talk about 6 things you can do with the Azure AI and Azure Local AI extensions, which are first-party extensions. They greatly simplify building Gen AI applications on Postgres.
And today I'm going to give a talk on how to use Postgres views to revitalize your complicated or outdated data models. And I think this is very relevant for software developers who are working in startup environments where your data model is constantly changing.
My name is Varun, Dhawan. I'm a product manager with Azure Postgres team at Microsoft. Today, I'm going to talk about top features that make Azure Postgres great for developers. I believe this will be an interesting talk for anybody who wants to start developing on Postgres, whether community Postgres or Azure specifically on Azure Database for Postgres.
Wow, what an amazing lineup of speakers we have today and an amazing program.
Yeah.
Okay, I guess it's time to get into it. So I am very excited to introduce Sarah Novotny. Sarah is a well-known open source champion, especially well-known in the Kubernetes community. She's also a tech executive known for her leadership in open source, infrastructure automation, cloud computing, and big data. Sarah has led open source ecosystem and strategy groups at both Microsoft Azure and Google Cloud Platform, and she sat on the Linux Foundation Board of Directors. Sarah's keynote title today is Why I Love Open Source Development and What I Learned from Kubernetes. So here we go. This is exciting.
Hi, I'm Sarah Novotny, and I'm a longtime open source community contributor. I've worked in projects and communities like MySQL, Nginx, and Kubernetes, to name a few. And today I'm going to talk about Kubernetes and the different things that I have learned and loved from that project. You may be interested in some of the tidbits and distillations that I've got from this time in that project, and I hope you enjoy. So, I love open source development. It is my favorite way to engage with creation of software. And I do this for a number of reasons. Every project is your project. When you come participate in a community, you learn and listen and engage with that community to understand how they interact. But the best possible part of it is you get to go participate and change and evolve and add your own voice to that project. So one of the things that I have found from Kubernetes and helped instill as a goal and a value in Kubernetes is that every person's voice is valued, and that doesn't necessarily mean that your choice and your work will be changed based on that, but that we are respected and engaged with for that voice. You need to feel a sense of ownership and engage with the project as if you can make a difference, because of course you can. This unique perspective that you bring, that I bring to every project we interact with is incredibly important. We are each an assemblage of what we have done in our lifetime, and that brings empathy and character and perspective and variety to problem solving and creation and solutions in the same way that we need effort and time and engagement in these communities. But that perspective, your unique perspective, is very important, and it helps us make a more robust project. It helps us make a broader, more integrated community. And you find that unique perspective in your project brings us to a better tool set, a better solution, and a better engagement in the open. One of the other big things that I know and have seen in all sorts of open source projects is monocultures. They're easy. They're really easy to fall into and to work in. If we're all thinking alike, it seems much simpler. We don't have to argue. We don't have to discuss different points of view. We can just go with the first thing, the fast thing, the thing we all agree on. But if we all come from the same perspective, that monoculture makes for an uncomfortable space for people who could make your project stronger. We really need to make sure, as we're working in open source, that we're looking to avoid a monoculture in almost every direction. Now, that doesn't mean that there are places where working along a single solution path is important or necessary. So I'm not suggesting that we have everyone writes their own components in different languages, because that, of course, gets complicated and doesn't work. One of the tricks that I use for many years is if there is a reason to work in a different language or a different perspective, then you need to take that focus and you need to consider where that is important. As long as you have more than one person who can work in that, building always a group, and building always the next most important thing in our communities, making sure that we're building for long-term sustainability. And that means you can't end up being a singular contributor in a space where you are the only person to work. So in the monoculture space, you're always wanting to bring in someone else, teach someone else, grow someone else, try to broaden your perspective, and more fun, more people, more engagement always ends up being better for the community. This is also a thing that we use in a lot of ways in order to make sure that people feel as if they belong. So if you happen to find that you are already in a bit of a monoculture, or if you find that you are the only person working on something, find a way to include and bring in someone else. That transitive trust, that engagement with another person to teach them, to help them feel as if they belong, to not be encouraging a singular, isolated person. That is all so very, very important in open source. You are building as a team sport. You're building in public. You are building in a way that is messy and human, and making sure that you are engaging with people as humans and making sure that they are feeling as if they belong and are a part of this project, this team, this tool set. That's incredibly important. It also is a gift to anyone who is new to a community or new to a project or new to a concept within a project. Making sure that you are open and engaging with them is incredibly helpful. Helps them feel as if they belong and helps them bring them along toward the team engagement of open source development. This also is a great way to figure out how you can always have succession planning. As it turns out, we all, none of us, I hope, want to be doing exactly the same thing forever and ever. I suspect most people want to retire someday or even move on to a new project or learn something new and different. So as you are including people, as you see people taking ownership and participating and feeling a part of the project, bring them in, work with them to help them understand how they grow within the project. And you as a leader, you as an owner of this project, end up growing a succession plan for yourself. These efforts, this work, all needs to be done in a way that helps make sure that the project outlives you, that the tooling outlives you, that the project's ability to engage and grow and adapt outlives you and outlives your own limitations. Kubernetes is a great example of this. 10 years ago, and Lord, yes, it's been 10 years. 10 years ago, we didn't think all the time about AI workloads. We didn't think all the time about how we were going to deploy AI pipelines. Now, none of this was invisible to us, but it wasn't the primary focus. And as our teams have grown, as the project has grown, as the governance and the community leadership have grown, we have brought in, or they have brought in, I'm not any longer a leader in Kubernetes because I planned my succession. As they have brought in new concepts and new individuals and new contributors, they have found ways to evolve Kubernetes that I did not dream of 10 years ago, from either a community perspective or from a technological perspective. This is one of the things that we really need to consider in open source. Open source isn't stagnant. Open source isn't a fixed point in time. There never is a done. Instead, we have projects that live on and projects that continue to evolve and projects that grow to fill new niches and projects occasionally that are no longer useful and end up being replaced. But there will still be someone using that project for many, many years, even beyond what your or my interests in maintaining it are. But there's always someone who is interested in helping. Which leads to my next point. Invest in the people who show up. When we started Kubernetes, we had a lot of new people showing up every week, every quarter. The people that stayed, the people that participated, the people who continued to bring their ideas and invest their time, even if they were different ideas or difficult people, we ended up finding ways to bring their unique voices into the project in a way that allowed us to have a stronger and ultimately more cohesive project. We set up values in order to make sure that when new people showed up, they understood how decisions were made. And when those new people showed up, we could invest in them and help them grow in alignment with the project. When you're always bringing in new people and always bringing in new perspectives and positions, you want to make sure that those people who have been leading are often helping others stand up and shine. That gives people, again, more sense of belonging, more sense of their own ownership in a project. And as it turns out, that means that they invest more of themselves in a way that allows the project to be stronger, that allows more people to come in and more succession plans to be developed. It keeps the project active and the community healthy. There's also always the opportunity to help and grow someone new. We've seen within these open source communities, people come in straight out of college, first internship sort of role, and then grow into maintainership, grow into an ownership of a particular sub-project, and of course, grow into their careers and their best, broadest selves. There is so much possibility in each of us as humans that a little bit of attention, a little bit of a sense of belonging, a big sense of ownership, and others helping you shine, make sure that you can be the best human as well as the best producer that you can be. So let's talk real for a moment. All of this investment, all of this belonging, all of this ownership is wonderful and important and gets the project moving, helping others do their best work. Incredibly useful, incredibly important. And all of that, especially for those of us who may have gotten identity mixed up with what we do, that can be damaging. And it's not just damaging to an individual if it's not managed. The individual, of course, is hurt. I've been through burnout a number of times, and that ends up hurting me first. But I behave in ways that don't align with my own values, that don't align with my community values, and actually end up damaging the community, damaging the project, not delivering things on time. Making sure that you build in a way that allows for cycles for people. There's a cycle of building, there's a cycle of restoring, there's a cycle of building, there's a cycle of restoring. That has to be built into the project, has to be accepted and understood and engaged with in a way that is good for the humans in your project. It turns out, maybe nobody told you, open source is made of people. The bits and bytes are byproducts and exhaust, but what we build are these communities that make cool tech. But these communities will last a lifetime. I have literally been working for 15 years in some places with community members from the MySQL community. I keep in touch with the Nginx community. I continue to see and enjoy and participate with people from the Kubernetes community 10 years in. All of this is what builds your network, and that network is what helps you get your next job. Now, in building that community, you need to make sure that you are caring for each other as humans. One of the reasons I love open source, because that's what this talk is about, is that there is an acknowledgement and an investment in the people side of development, and not simply the production of a piece of code or the production of a industry motion or the production of profit. I find that these communities being self-organizing, these communities often being led or rabble-roused by underrepresented minorities to challenge the monoculture, that makes a more empathetic and engaging and healthful way to build software. We don't do it perfectly, There's lots of problems with burnout, and that's why I want to talk about it here for that moment. But I want to make sure that we realize it's not, I can't prevent burnout on my own. I have to prevent burnout in conjunction with my community around me. I can't prevent burnout if I don't have others helping me shine. And I can't keep someone else from hurting unless I am investing in them as well. In the US, very much we're seeing a decline in community. In a lot of cases, a lot of the organized communities that we used to have are not as pronounced or as profound in people's lives right now. But I feel like open source contributors have that sort of society around them, that sort of community in their projects. And now we get to keep working on how to make it better. The how we make it better, of course, is absolutely communicate. The only thing I can say out of these varying projects is, doesn't matter how many times you say it, how many times you publish it, where you publish it, someone is not going to have read it. Someone is not going to have heard what you said. Someone will ask you to repeat yourself, ask you to explain something. And that's okay. That's human. That brings moments of connection. That brings engagement one-on-one. That brings engagement in one-to-many. And it brings engagement in person sometimes. So when we're communicating and over-communicating everything, recognize that there need to be multiple formats and multiple ways of communicating a message. This doesn't mean copy and paste the same message in 5 different platforms. This means make sure that you've given some amount of communication that is durable. So the mailing list where all the announcements go, some that is ephemeral like social media. And of course, you see on the screen, at Sarah Novotny, you can find me most places on most social media at that handle. But as you are engaging with communicating, you're doing this in durable formats, in ephemeral formats. You're doing this in video formats, in, streamers behind airplanes at event format. You need to make sure that you're getting your message out in as many ways as you can. And there still will be people who miss it. And that's okay. This doesn't make everything, none of these suggestions make everything perfect. They are all and always trying to iterate to a better project community. And then, of course, my last, but possibly most primary point in all of this work, and it's lots and lots of work to do this, find the fun. Find the people that are excited to work with you. Find the people that draw energy into the project. Find people who give you energy. Make sure that as you are building, you are also finding those very human connections. One of my favorite stories about Kubernetes is the fact that even as we were struggling with the breadth of this project, the project became huge in about 3 years. One of the running jokes was that we had too many special interest groups. So we had special interest groups for the core, and we had the core of the nodes, and then we had the special interest groups for APIs, and then we had an architecture group, and then we had all of these specialty focuses, which was great, but made that communication problem that much worse. Many to many, for all the database nerds that are watching, is still a problem. So as we saw this special interest group spread, we actually sort of leaned into it and ended up building what were more social special interest groups. So there became these gag special interest groups like SIG bouldering, which went out and climbed rocks at events, or SIG late night. And these were all special interest groups that ended up being more socially focused. And of course, it was in part making fun of ourselves. As we had so much sprawl to keep track of, we were able to, in a quirky way, continue to say, no, we need to have fun with this, and we need to connect to the human space and engage with the reality that open source is made up with people. So if I can leave you with one single thought, It is this. If you spend as much time on open source as most people I know do, make sure that you are looking at ways that this also feeds you, because that is the best way to prevent burnout and to make sure that you have the energy to communicate and to help others shine and to grow your project in a way that allows you to have another thing to talk about, another project to share. And then as you are building this, you build out your succession. So when you are ready, you are able to step away slowly, possibly, or very quickly if something terrible happens or something wonderful happens. Step away and go ahead and move on to whatever's next. In this, I hope you all can find a way to have fun.
Well, that was so interesting and really valuable for me. I know in the Discord channel, I chimed in quite a bit. Personally, I feel like the Postgres community has a lot of the same concerns and maybe not all implemented all of the solutions that that Sarah talked about. So it's really good to hear other open source communities talk about how they've solved these issues and how they managed to keep going, because I don't know how everyone does it.
And I really appreciate it when a leader of Sarah's reputation takes the time to focus on caring for people and helping us remember that we have to work together, and how we work together matters. It's a great reminder that what we're building is important, but how we build it is going to matter in the longer term. So
Yeah.
thank you, Sarah. Thank you, Sarah, very much for your talk, for your keynote talk.
So up next.
So sorry, I just wanted to mention to people, we mentioned that we've got categories of talks, and so we've sort of we put this keynote in the community talks category, and there are others. So we wanted to let you know to go look in the other live streams for other talks like this, and throughout today's live stream, we'll try to remind you where you can go to find other talks like the one you just heard. I'd like to also remind you that you can, and we really appreciate it if you fill out the survey. Sorry if we're being a bit repetitive here, but we really like survey feedback, both for talks and for events, for the event as a whole. And you can fill out the talk survey once for each talk, please. Speakers love feedback. And a reminder that the speakers are in the hallway track on Discord in the #PosetteConf channel. Sarah was just answering questions, answering about nuances, and just participating in the general chat here during.
And I noticed that our next speaker was active in the chat already, so we know that Bruce is going to be on there answering all of your questions.
Exactly. You can even get ahead if you want to.
So I'm really excited that Bruce's talk. Bruce Momjian has been working on Postgres since 1996. I'm lucky enough to get to interact with him on the mailing list and at conferences. We were just on the channel talking about how valuable those in-person interactions are. And Bruce has so much experience with developing Postgres, but also with meeting users out there at all of these amazing events, talking to them, understanding their use cases, recruiting new Postgres contributors. He was a co-founder of the Postgres core team and is on the core team to this day. And he's just, really our top evangelist for open source Postgres around the world. Actually, if you go to his website, you can see his calendar, and it's all of the events that he'll be at. I got distracted looking at all the links in his website earlier. And you can see where you can interact with Bruce. He's a master educator, and he's given many of my favorite Postgres talks. I really enjoy his talk on window functions, which you can access on his website. And this year he's at Posette. He's going to be giving a talk that's a follow-on to a talk that he gave at Posette in 2022, I believe, about the Postgres query optimizer. And this time he's going to get into a few more details about sort of beyond joins and indexes, what's titled. But I got a sneak peek, and it looks like he's going to go into some of the different plan nodes and how they work and what they're for. And I'm excited because Bruce has said that the Postgres planner is his favorite subsystem. So it's exciting to get to hear him, an expert on it, talk about it.
Looking forward to it. Here we go.
Hi, I'm Bruce Momjian, Postgres core team member and EDB employee. 2 years ago, I gave a talk at CitusCon called Explain the Postgres Query Optimizer. And today I'm giving the follow-up to that talk called Beyond Joins and Indexes. The talk is basically taking, building on the basics of Explain the Query Optimizer, talking about all the other things that the optimizer does that I didn't get a chance to talk about 2 years ago. So I'm looking forward to this talk, and I hope you enjoy it too. This is, again, a follow-up to a previous talk I gave 2 years ago called Explain the Query Optimizer. If you're interested in the slides for this talk or any of my other 62 talks, the URL right here is where you would go to find that. And, of course, the QR code works as well. So, basically, 2 years ago when I talked about Explain the Query Optimizer, I covered the basics of the optimizer. That is, how does it work? How are optimizer statistics used? What are the various join methods possible? The various scan methods, including use of indexes. And I concluded talking about the limit clause. This talk is going to talk about everything else, every other thing that the optimizer does. And frankly, it took me a long time to basically distill this list down to those sort of, I want to say the word fancy or sophisticated methods that the Postgres optimizer can use. And you will kind of, at the end of this talk, get a feeling for how much it's capable of doing. One of the great things about SQL and relational databases, frankly, is the ability to take a query that's normally written in an English-style language and convert it to something that is optimized and executes very quickly. And we're going to go through, again, 43 examples of this. As you can see at the bottom right, we do have 68 slides, so I'm not going to be able to go into a huge amount of detail on anything, but I will give you a general idea of what it does and why this thing is so cool, at least to me. We do have some controls that turn on and off various optimizer settings. In the top left, these are all the settings that I covered in my previous talk explaining the Postgres Query Optimizer. And what I am going to talk about in today is this middle section, these incremental sort here all the way over to TIDSCAN. The bottom left, bottom right, where we talk about partitioning. I do have a separate partitioning talk where I cover those. And again, there's a link there at the bottom if you're interested in that material. So let's start with the simplest one. The simplest one is a result node. It's basically just returning a constant. Not a whole lot of fancy things we can talk about here. One thing I do want to highlight, though, is there is a link here at the bottom. All of the SQL you're going to see today is in that SQL file. If you download the slides or you go to that URL, you can actually run this presentation and watch all of the output that you're seeing today. Value scan. This is actually a special scan node for the values clause. You may not have seen the values clause, but the values clause is part of the SQL standard and allows you to basically output multiple rows. A function scan, it would be used if you have a function that returns multiple rows. In this case, generate series is an example of that. And you typically put that function inside a from clause so that the function becomes a source of rows which are used in the rest of the query. Incremental sort, this is the first one that I think is sophisticated. And we've had this for many years. It effectively allows you to use an index for the early parts of an order by and to do manually sorting for the latter parts of an order by. Here, we have an index, we have ordering by X comma Y. We have an index on X, and we're going to do an incremental sort. We're going to use the index for the X part. We're going to manually sort the Y part. This is the first diagram that you're going to see that covers basically internally what is going on inside. As you can see on the left, all the blue is pre-sorted. The pink side on the left is not sorted, and incremental sort is basically retaining the blue sorted part and merely sorting the pink part within equal values of the blue part. That's how a multi-column order by works anyway, but we're not resorting the X field. We're using the index to pre-sort that. The unique clause used particularly for something like distinct. If you're familiar with the distinct clause in the target list, as I'm highlighting here in blue. And another way you can get distinct is a union. This is a special clause that joins two selects together. This is not the same as union all, but actually union where duplicates are removed. And that's why the unique clause is used here. Here's a diagram of that. To do unique, we basically sort the result, and then we remove adjacent duplicates. That's the easiest way to get uniqueness. The append node, you would primarily see this with union all. Again, union all does not remove duplicates. It merely appends the second result of the first, and we get a very simple append operation out of that. Merge append, this is a pretty sophisticated capability. If you're familiar with a merge join, it's basically a merge join style union of two result sets, but you're appending the values together instead of joining them. Here we have a query up at the top where we order by two, we have a values clause, we order by the first values clause, we do a union all, we order by the second one, and then we effectively have two ordered result sets. We want to append them together. That's what the append node does. We just learned that. So what we're effectively going to do is we're going to take the two nodes, we're sorting them, we're ready, and we're going to merge append them, which means we're going to take two result sets. We're going to take the lowest value out of each result. We're going to put that into the result, and then we're going to take the next lowest value between the two sources. That will be our next result, and then basically walk down through the results that way. Subquery scan and hash setup. This is something you would use for something like an accept clause. An accept clause is where you're basically removing rows from the first result that appear in the second result. And to do that, we effectively need to create a hash. So as you can see from left to right, we take the two results, we join them in a hash, and then effectively we can see which cases where we have a result from the first that does not have an accept or a removal from the second. So any case that has a 1 result without a 2 result is effectively what we output. You can see from the results here on the right, 7 and 12 are the only cases that have a 1 without a 2 in terms of sources. And that's why you get the 7 and 12 coming out of that result. Sort up, this is for intersect. This is where you have two results. You want all the rows that are in both result sets. And in this case, we do something very similar to unique. We basically take the two result sets, we sort them, and then we figure out which ones have a 1 and a 2 for the result. And again, in cases where we have a 1 and a 2 together, we output those. A 3 and a 6 are the only ones that are in result set 1 and result set 2 at the same time. Materialize, this is effectively a node that takes particularly a sequential scan in this case and brings it into memory. It's a case where we bring some results into memory. Usually it's not a big result set. And we're going to do it in memory because it's easier than if we're going to revisit something over and over again, in this case, a not equal join. It's faster to do it in memory than to be reaching out to the shared buffer cache over and over again. And that's what's happening here. And we're just basically materializing the right-hand side into local memory, and then we do the join on the left here. Memorize, this is kind of a new one. Introduced, I believe, in Postgres 14. This is a weird one that I wasn't super excited about. It has all these weird requirements of when we actually use the node. But surprisingly, there's a lot of cases where Memorize speeds up queries. So the requirements in using a memoize is you need a lot of duplicates in one of the result sets, and it needs to be too small for a hash join. So that's your one requirement. The second requirement is you have a query, a result set that's too big for a hash join, and it's also unique. And then you also have an index. So again, you can see why I was not super excited. It feels like, is this really going to be used at all? But when you think of the thousands and millions of queries that are run, there are a large number of cases where this is happening, many more than I realized. So here's an example of one where we're doing basically a small table joined to a medium-sized table, and we already have an index, and you can see the memoize happening here. And we have a nice URL there at the bottom if you want more details. But what memoize effectively does is it allows you to create. Remember what I talked about materialize, and it takes the results out of shared buffers and it moves it into memory, and it's more efficient doing it that way than having to go to shared buffers all the time for the rows if you're repeatedly looking at the same rows. Well, in this case, we've already defined that the right-hand side is too big to be pulled into memory completely. So what we do is we just cache the frequent lookups that we have. So we kind of create a materialize, but not a full materialize. We create a cache of materialized values. So we basically start on the outer side. We do a lookup. If the lookup shows that the entry is not in the cache, then we go to the shared buffers. And if we find a match, we copy that into the cache. So later lookups can use that copy. If we find that we don't have an entry, we have a separate recording that something was not found, that we've remembered that. So we don't continually look up missing entries either. So what happens here is effectively we're now doing a join. And again, this is a case where we have a lot of duplicates on the outer side. So we're going to continually be looking for the same values in that cache over and over again. But because it's smaller, we don't have to bring the whole thing into memory. It's actually really efficient. And again, this was a big win for Postgres 14. The group clause, you might not have realized you can use the group clause outside of an aggregate, but you actually can. It just basically removes duplicates. If you're curious about how that works, again, feel free to read that text at the bottom. A group clause basically takes multiple rows and distills them down to one value. Aggregate, you've seen this before. Here's a simple count. Here's a group aggregate where we have count and group by together. Okay. And we're basically taking multiple rows, moving them into a single row if they have identical matching columns defined in the group. But we also have a special aggregate field that allows us to take those multiple values and sort of aggregate them together, whether it be sum, average, standard deviation, maximum, minimum, and so forth. That kind of allows us to kind of shrink those down. And that's what group by does effectively. Hash aggregate, this is a case where, and again, it's different than a hash join, okay? This hash aggregate is where you're aggregating not necessarily by bringing things down, but by creating a hash and then accumulating the values in the hash. And this is kind of the way it works. You have the outer side, or you have your full table on the left, and you're basically going to distill that down to specific values on the right. But again, we're doing this in a hash, so it's very easy for us to find matches and to aggregate those. Mixed aggregate, if you're familiar with rollup, this allows you to kind of do several levels of aggregation at the same time. This is, again, sort of the way it works. You're getting an aggregation, but then you sort the result and you can get other results. Sort of you're aggregating, and then you can do further operations on those aggregates. Maybe you want to find a total. You want to report the total and then the individual aggregate total separately. It's kind of cool. Window aggregates, I do have a long window function talk. Again, URL there at the bottom. But effectively what window aggregates do is to allow me to do aggregation across multiple rows, but I do not lose the distinctiveness of the individual rows. So as you can see, I have, 10 rows or something on the left. I have 10 rows on the right, but I'm able to aggregate across these groups at the same time. And that's really the special value that window functions give you. Getting into parallelism. This is, again, a whole complex field of what Postgres can do for parallelism. I have several slides related to parallel operations that Postgres can perform. The ones I'm going to talk about first are parallel sequential scan, parallel aggregate, gather, and finalize aggregate. Here, a very simple sum on a large table effectively creates two parallel sequential scans at the bottom, which then become partial aggregates, which are then gathered together in the primary backend process and then finalized. And hopefully you can read this, but again, going from left to right, we have parallel sequential scans happening in two ways in the same table. So we only have one table here on the left, but you can see I have two worker processes. One is parallel scanning from the top, and one is parallel scanning from the middle down. Going from left to right, I then aggregate these results together into a sum, for in this example, between the two workers, and then I send them to two workers send them to the primary process, where we then go to gather. We gather results together, and we issue a finalize, and the finalize again is returned to the user. So you can see why a large sum on a large table can be sped up by using parallelism. Gather merge, a little different. It's sort of, we're getting a little closer to merge join or merge aggregate, right? Remember, or merge append, right? See, that merge concept is sort of reappearing. Here we're taking a large table, we're doing order by. So how do we do that? Similar process. We have a large table on the left. We have two parallel sequential scans working. These two parallel sequential scans are individually, each worker is sorting its own results. So we have two sorts going on in parallel, okay, the top one and the bottom one. And then when we want to return the result to the user, instead of using a partial aggregate, which we can't because we're not using aggregates here, we're going to do a merge gather, similar to the way we did a merge append. We're going to take the lowest value from either of the result sets. That'll be our first result. We'll then go advance, take the lowest value from the two result sets. That'll be our next result. And we just keep going down until we get to the last row and the last result. And eventually we end up with a sorted result. And we've been able to sort them independently. Again, you can see that merge capability reappearing here in a parallel situation. Parallel append. This is very similar to the merge append, where we're just appending results. Here we have a huge table, union all with a huge table. We just want to append the one huge table to the other. And again, this diagram is a little bit crazy, but we actually have four parallel sequential scans going on because we have two tables. Then these are being parallel aggregated into two result sets and then sorted independently and then appended, parallel appended into the results. So again, because if you notice, we do have an order by here, so we have to sort it at the end. But the point is that we've been able to append the two. We've been able to do two sequential scans in the same table and then merge those together. Parallel hash join. This is the case where you're doing a join in parallel. I know this diagram is kind of off the charts, but I'm going to walk through that. You have to kind of go like back and forward here. What we're going to do is we're going to take this table in two pieces. We're going to take this in two pieces. We're going to create a shared hash of this large table. We have two parallel sequential scans on the same table. We're going to create a shared hash between the two workers, and then the outer side is going to do lookups against that shared hash and then report their results back to a gather node. I know it sounds like crazy, but it actually works really well. Again, this does allow us to take the inner side, do two parallel scans, and create a parallel hash, a shared hash that we can then look up from the outer side. Moving on and going to some of the more sort of SQL specific nodes that we have, common table expression scans. I do have a very popular common table expression talk, again, here at the bottom right in blue. Common table expressions are basically the ability to run a query and then use its result in a later part of the same query. You can see that here. And effectively, all we do is we basically create a common table expression, what we call a CT source, and then we can basically use that in a later query. You may be more familiar with recursive common table expressions. This is very good for walking through trees and sort of dynamic content. Again, you can see in blue here we have the with recursive. We also have with recursive union. This is the way it works from the SQL level. You have a primer that loads into source, and that source then feeds into a second query, typically after a union all, which then feeds up into source again, and you get this loop going on. Internally, this is the way it looks. You have your sort of primer that goes into the recursive union. It then loads up a work table. The work table then is fed up into the recursive union. And as you're generating rows through here, you're effectively appending results to the CTE source. And as soon as your work table's empty, your common table expression at the top is done. And then you use your CTE source in the rest of the query. So effectively, you're looping around the upper part of the common table expression until it returns no more rows. Then once it does, that section is finished. We have a CT source that passes down to the lower part of the query. To get a little more exotic, project set would be used if you have a row producing function in the target list, not necessarily in the front clause, which you talked about earlier. Here we're putting this row result function in the target list. Again, Postgres can handle that. If you're doing for update, you get lock rows. If you're doing a sample scan, a table sample, we have a special node for that. If you're doing XML table, we actually have a special node just for XML table because the syntax you can see is really unusual. If you're using foreign scans, we have the capability of doing that. If you're doing debugging or you want to look at physical rows in storage, those are called TIDs, tuple identifiers. You can actually use this syntax right here. There's an invisible field called CTID, which allows you to specify, for example, page 0, the first tuple on page 0, and I can actually access that directly without having to use an index or a sequential scan. I can go right to that location. And this is effectively the way it works. If you're doing an insert, we create an insert node. If you're doing an update, we do an update node. If you're doing a delete, we do a delete node. We do not create nodes for truncate. Truncate is not what we call a DML. It's a DDL. It does not go through the optimizer. And therefore you cannot run explain on it. It doesn't create a special node. It's sort of its own thing because truncate effectively removes all the rows immediately from a file. If you're using the merge command, we do have a merge node that allows you to effectively run the merge operation. Semi-join, this is kind of interesting. I didn't really understand all the details here till I sort of dug into it, but a semi-join is effectively similar to an in clause, except you stop on the first match. So it's sort of like exists is saying, do I have any rows? If I do, return the outer row. If I don't return it. So it's similar to a join between two sources, except you're stopping after the first match. That's why it's called a semi-join, because you're not joining all the rows, you're just joining the first match and stopping. Another example of semi-join would be an in clause. Again, is the value in that subquery, yes or no? In and exists are actually equivalent because they handle nulls the same. An anti-join, this is kind of interesting. This is when you're starting to use something like not exists. Again, same logic. Is there a row in there or not? I stop the scan after my first match or my first negative result. A not in, and this I learned as part of doing this talk, is a case where, remember I said exists and in are kind of the same in terms of their handling of nulls. Not exists and not in are different in their handling of nulls. If you've ever gotten tripped up by this, be careful. If you're not in returns a null result, you will not get any rows. So just be aware of that. Again, feel free to read the text at the bottom. This is kind of a cool case if we know you're not going to return any rows because we have a unique index and we do a left join, the join goes away. I was kind of surprised by this in doing my research for this talk, and that's kind of cool. It knows it doesn't need to do the join, so it doesn't do it. I didn't cover tuple store and custom scan again. Not really important. So again, I'm loving the fact that I was able to take a talk I did 2 years ago that gave the basics and was able to really flesh it out in a comprehensive way to give you a good explanation of all the power that is available in the optimizer. And again, Postgres is continuing to get better. I just worked on the Postgres 17 release notes. There's a lot of optimizer improvements coming, even in this release, again, due probably September, October of 2024. Thank you for attending this talk.
Wow, that was great. I feel like I learned some things too. I didn't know about some of those node types, and it was cool seeing some of the newer, nodes like Memoize. And my coworker David Rowley worked on that, and it feels like a celebrity call out to see his node featured in Bruce's talk. So that was very cool.
Well, I'm certainly going to need to watch that again. And I love it that Bruce sort of did a multi-part presentation over the course of 2 years in our conference. So that's fantastic by Bruce. On that note, so first I want to say that Bruce's talk is sort of categorized as one of the core talks. There are many others across the 3 live streams. Today, we're going to hear from KK and Melih, as well as Newvick. And those are all categorized as core talks, so just stick around. And since Bruce mentioned that he gave the first part of this talk 2 years ago, and I should say Bruce also gave a talk last year on AI and Postgres. So we wanted to give you the links to go find that content. Please don't do it now. Wait until after this conference. But you can go find the old the playlist from last year's conference and the year before. And there are other speakers like that we'll hear from today and throughout the conference that have spoken at these conferences before. So if you find a speaker you like, there's a good chance that they've given another talk at this conference. So please go watch that.
And just a reminder that the virtual hallway track, which we've been discussing during Bruce's talk, during Sarah's talk, go to Discord, to Posette Conf channel, and there's a lot happening on there. I think getting the value out of this live stream is also using the virtual hallway track. So I encourage you to go there. And while you're there, you can show off your Posette swag if you already have it. And if you don't, go to aka.ms/Posette swag. And I think the codes, the codes are being flashed right there. So you can use the code, to get your sticker packs. And if you're very lucky, maybe socks. And also just a reminder that the speakers love it when you post about their talks and how much you enjoyed them, and use the Posette Conf hashtag on any of the platforms where you're doing that. And
it's time to introduce Adithya Kumaranchath. Adithya is an architect at Microsoft. He works with customers in several continents and across several industries, and he helps them succeed in their data migration and modernization projects. Earlier in his career, Adithya worked with Oracle, and for the past few years, he's been helping customers migrate to PostgreSQL on Azure. Adithya is one of the the speakers that had a talk at last year's conference, and he talked about partitioning strategy for Oracle to Postgres migrations. This year, today, he'll be telling us about lessons and learnings from customers migrating to Oracle, from Oracle to PostgreSQL. Here we go.
Hi, thanks for joining the session. I'm Adithya. I'm from the Azure product group. I help customers migrating their workloads to Azure, and I've been working with many customers around the world across different industries in complex PostgreSQL implementations, and I've been helping them in resolving their performance and scalability issues. A little breakdown of the session for the next 20 minutes. I understand that this is very limited time to deep dive into each of these topics, but what I would like to do is talk about the key challenges, solution, and outcome of a couple of engagements, and I believe that this would be very useful for anyone who's considering to move to PostgreSQL from Oracle. So this session is mainly targeted for anyone who wishes to migrate to PostgreSQL from Oracle. Many customers I work with are migrating to PostgreSQL from Oracle. Let us look at what their reasons were to migrate to PostgreSQL. One of the main reasons customers migrate to PostgreSQL is because it is open source. And open source solutions often give customers the freedom to choose, and it allows them to manage the software in-house. This avoids dependency on a single vendor. Ultimately, because of this, there is a reduced total cost of ownership, because there is less cost for software acquisition, there is less cost for maintenance and support. And this, in turn, contributes to lower total cost of ownership. There is a lot of flexibility when it comes to PostgreSQL. So PostgreSQL's extensibility allows customers to add functionality without any vendor restrictions. And because it's open source PostgreSQL, customers have access to the source code, they have full transparency. It allows organizations like big banks, financial institutions to modify and customize software to meet their specific requirements and goals. And talk about Postgres. Postgres very well integrates with a lot of tools, platforms, and other technologies. So its ability to easily integrate with other tools and platform helps customers to easily integrate with their platforms. We all know the amazing PostgreSQL community, and they are very active, they provide support, and they try to improve the engine all the time. So my customers, including me, I'm actually amazed how active the PostgreSQL community is. In most of the cases, if you have a query, you drop down a question in the community DL, you're sure to receive a response within an hour or less. And that's how amazing Postgres community is. So it is not easy to migrate from one technology, database technology, to another. We all know that. And with migration comes a lot of challenges. These are a few key challenges that come to my mind when it comes to database migration. The schema migration and the data migration being one of those. So the schema migration is quite a challenge because they pose several issues during migration. The most common is not setting the right data types between the source and the target during migration. Usually, when you don't set the right data types between the source and the target, what happens is it is a possibility that there is a miss in precision, and that can lead to data truncation. And there are cases where the data types are mismatched. And after migration, what we find is that in PostgreSQL, the table explodes because the size of the table is far more huge than what you observed in Oracle. Then after migrations come the challenges of missing indexes. There's always a possibility that the queries after migration start to run slower in PostgreSQL. And after investigation, you find out that there are missing indexes. You have to apply those indexes. So that's also a possible challenge. The data migration itself is a big challenge when it comes to migration, because the time taken to migrate is directly proportional to the size of your database. So it is always a challenge when it comes to data migration. And if you have a lot of Oracle packages in and you are using a lot of Oracle native features, then that also becomes a challenge, because once you migrate to Postgres, you will have to rewrite those Oracle specific queries into PostgreSQL store procedures and PostgreSQL supported features. There are always query syntax differences as well. For example, in order to select top 10 rows in Oracle, you would use a row num where row num is equal to 10. But then when it comes to Postgres, you'll have to rewrite that to use a limit. And there are joins as well, which Oracle supports and which are not supported in Postgres, which you will have to rewrite. And talking about performance is also one of the key challenges when it comes to migration engagements typically. So when, of course, customers achieve a huge cost savings when they migrate off Oracle and migrate to Postgres, but without performance on par or better than Oracle, the whole business case of migration becomes a moot point. And it is only fair that customers expect that their performance is on par or better than Oracle once they migrate to Postgres. So in most cases, this becomes a challenge, because after migration, customers find that the performance is not on par with Oracle at times because of the way the queries are written. And like I mentioned, there are indexes missing, statistics needs to be applied. But in most cases, application and databases will have to make some adjustments in order to ensure that the queries are on par with Oracle. And after they have done those changes, in most cases, we find that the performance is on par or better than Oracle. The next key challenge is testing. I cannot stress the importance of testing in a migration engagement because there is change of code involved. So your application goes through change of code, your database objects have changed, the data types have been mapped. So a thorough application testing is very much needed in case of a migration project. Most of the mission critical applications require minimal downtime, and they need to have a right fallback strategy in place when it comes to data migration. So that is also one of the most common challenge in terms of migration, because customers need to run both these platforms in parallel for some time in case of mission critical applications. And in case there is a failure, they need to fall back to the original system. They should be able to fall back to the original system in case something goes wrong, so that they can reattempt a migration at a later point in time. So this is always a challenge to keep two systems alive for an extended period of time. Fortunately, we have some great tools in the marketplace to do it, like Stream, like HVR, that can be used to keep both these environments in sync. So there are many more tools in the market which customers use, but these are a couple of the tools that I've seen many of the customers use. Now, let's look at some tales from the field. So the first story I would like to talk about is a bank from Southeast Asia. They run a trading application that is highly transactional in nature, and it processes, and the trading application actually processes 1 million messages per minute. The key challenges that the team went through was mainly data type conversion. So they had complex Oracle data types, specifically hierarchical data types, and they had to change this to PostgreSQL and required significant effort. And one of the key challenges that we faced during that migration was that they had a 2 terabyte table in Oracle, and after they migrated to PostgreSQL, the customer was shocked because the same table was now 10 terabytes. So basically, this I would like to tie it back to the point that I raised before about data type mapping. So after an investigation, the customer found out that the Oracle table was compressed, and in Postgres, the table exploded basically because of the incorrect data type choices they had made and the ordering of columns. and they were not able to use of the native dose compression that is applied in Postgres because of the incorrect ordering of columns. So that was one of the key challenges that we faced with this customer. Like I mentioned earlier, performance testing is one of the key aspects of migration. After migration, this customer ran multiple cycles of performance tests in order to ensure that the queries performed on par with Oracle. So after migration, the customer identified top N queries that like a comparison, and they ran it on Postgres, and they found that those queries were not working or not performing on par with Oracle. So then there were multiple performance test cycles which the customer had to go through in order to ensure that the performance was on par with Oracle. One of the cool tools that they used during the performance test was pgvector. So pgvector is an amazing log analyzer tool that comes handy during performance tests. It is an open source tool, and it gives you a detailed report on the top N queries and the detailed stats about those queries, why they are performing slow. So I'll drop in the link for pgvector here, and maybe it will be useful for your performance tests. And the approach that the customer took was a phased migration approach. So what they did was, at the start of the migration, they prioritized all their critical applications, and they approached. So they had a number of databases which had to be migrated, and a number of applications, of course, to be migrated. So what they did is that they prioritized in a way that they picked up the smaller applications or less critical applications first. And as part of this, they established a process in place, like a migration factory process in place, where they identify the tools and technologies required for migration. They set up deployment pipelines, and they did an iterative approach to the whole migration. This actually helped them because of that, they gained confidence and experience in that process, and they were able to use the same learnings that they got in migrating those smaller database and apply it much better and much efficiently in the migration of the larger database. The other thing that they did was they were always engaged with the PostgreSQL community. So whenever they hit a blocker in terms of PostgreSQL, or they had a question regarding performance or monitoring or any relevant PostgreSQL topic, they would drop down an email to the PostgreSQL mailing list, and the community is pretty active, and they would receive a reply or a feedback instantly within probably a few minutes, or maybe even less than an hour, and that helped them to gain confidence and get expert assistance when it comes to Postgres related topics. So the result of this was the customer achieved huge cost savings because of this migration, because there was significant reduction costs in Oracle licenses, and the performance was significantly improved because of the number of performance tests that they had carried out. They ensured that all the queries were tuned, all the queries are performing on par with Oracle. So they were able to actually achieve better performance than in Oracle after migration, after they did all the tuning and fixes. So now let's look at the other customer. The other customer that I would like to talk about is a media company in Europe. The main driver for their migration was that they wanted to adopt open source technologies, and they wanted to avoid vendor lock-in. They migrated from Oracle as well and they also wanted to reduce cost, of course. And they also had a lot of AI-related workloads that ran batch processes, which drove advertisements. And they had a lot of data ingestion pipelines, which would run in overnight batches. And there were a lot of analytical queries that were executed overnight. And the interesting fact about that was they had batch processes run overnight and produce reports, which was sent to top level management for decision making on a weekly basis. So you can imagine how data accuracy is so important for this customer, because you could imagine, important decisions are being taken by top-level management based on these reports. The main challenge this customer had was the SQL syntax differences. And in reality, databases don't exist in isolation. They exist in solidarity, between a lot of applications. So there are a lot of applications that connect to a database, and they had applications running in .NET, Java, and these applications had embedded PL/SQL queries. So that was one of their main challenges, because they had a lot of applications which had embedded PL/SQL queries. So as part of the migration, what they had to do is they had to change these applications, which kind of was a difficult one, but they were able to do it. They knew exactly what had to be changed. They used tools to sniff out PL/SQL, embedded PL/SQL code, and then change it into pgvector code. The other challenge that they had was database schema conversion, because in Oracle, they had multiple databases, and they had to migrate this to PostgreSQL into different schemas. And they had a lot of cross database queries as well. And this was a challenge for them, because they had queries which used to run across DBs. Now their applications had to remove all of that dependency because it used to query multiple databases. Now it's all residing in a single database in a single schema, and they had to do some refactoring based on that. But this is a challenge specific to this customer. So that was also a challenge that the customer had. What the customer did was that they automated the whole migration process into deployment pipelines, and they created APIs using Ora2PG, which used Ora2PG behind the scenes, and they kind of automated the entire schema and data migration. This is really cool, because then they were able to use Ora2PG and they were able to fire those APIs that they built on top of Ora2PG and fire database migration in an automatic fashion in demand for all of the other databases. It's kind of helped them to make the migration faster for the other databases. And they had also implemented comprehensive testing to ensure that the application functionality post-migration was working exactly the same way as it used to work before, along with performance. Because remember, like I told you, there were many applications which were connecting to the database, and they had to endure a lot of application code changes because of those embedded PL/SQL queries. As a result of this migration, they had a reduction in cost. So they had substantial savings on the database fees, because now they didn't have to pay anything for license. They also gained operational efficiency, because they had developed the deployment pipelines, automatic deployment pipelines. And so they could create these migrations faster. They could basically do these migrations at a faster rate. And using Postgres, they were able to actually achieve better performance than Oracle. One of the most common and interesting observation from both of these customers is that in the beginning, both of these customers wanted to migrate to Postgres in a virtual machine. So both of them executed a POC, migrating from Oracle to PostgreSQL in an IS machine, in a virtual machine. But then eventually, along the way, after they reviewed the requirements related to high availability, DR, and about how they could scale this environment and all of that, they discovered that they could adopt cloud, and they basically understood that it would be much easier for them if they just moved to a PaaS service. So they chose Azure PostgreSQL flexible server as their target. So they did a quick POC soon after they tried. So first they tried migrating from Oracle to PostgreSQL in a VM, and then they understood that the parity between between Postgres in a VM and the managed service that Azure offers is pretty much similar, and both of them run on open source Postgres. So they did a POC with managed Postgres, which is Azure Postgres for flexible server, and they understood that the whole management of the database was extremely simplified, because now they understood that they don't have to do operating system patching, they don't have to do updates, minor updates on their Postgres version. All this is managed by Azure. They understood that they don't have to do any kind of backups because, again, the backups are automatically managed by Azure platform, and the backups are snapshot based. So they could actually do point-in-time restore to any point in time if they wanted to. So in case there is an issue with the database, in case they have corrupted the data in the database due to their pipelines, it's an easy way to just restore a copy of the database from point-in-time restore, through point-in-time restore. So they understood all of these points, which kind of was very convenient for them, and they could also scale their workloads independently because it's a managed service and scaling is instant. You can basically scale your services according to the needs of your workload, and also they have read queries which can be forwarded to read replicas. So it is possible for them to now stand up a read replica, and redirect their read queries to the read replica with a click of a button. The same thing goes for disaster recovery. They could create cross-region read replicas and they could use it for disaster recovery purpose. And in terms of high availability, it became much more simpler because you always have a hot standby and automatic failover because you are now moving to a PaaS service. So these are a couple of decision factors and a couple of things which they observed after they did the migration to PostgreSQL in a VM, and soon after they decided that Azure Postgres Flexible Server was the right target because that reduces their operating costs by huge, and that reduces their total cost of ownership significantly because now they didn't have a team. They didn't have to have a team looking after the resource 24/7, managing the update cycles and so on. So that was something that was pretty much common between both of these engagements. And with the managed service, they also got extensive monitoring and analytics capabilities, which they could leverage. So there is log analytics and the query store, which they could use in order to do extensive monitoring of the resource. And that also integrates very well with their dashboards, with their monitoring dashboards, existing monitoring dashboards, and centralized monitoring system. So they are able to manage all of their requirements successfully. So a few tips and tricks, and to summarize what we have covered so far in the session. So the key thing is that we need to identify the top queries as part of the planning. So that was one of the key things that we need to do as part of Oracle to PostgreSQL migrations. You can get the top queries from your AWR. Those can be taken as a baseline or a benchmark to assess your performance after migration. And this is what both of these customers did, and this is what most of our customers do. They analyze the top N queries. You can get it from an AWR report, and then ensure that after migration, these top queries are run in PostgreSQL, and the performance is basically measured against those queries. And right sizing is another critical factor that needs to be done. So you need to look at the AWR report, understand the key metrics from AWR report like IOPS, CPU utilization, RAM utilization, and then map it to the relevant SKU so that your target is appropriately sized. And you can get these details from the AWR report too. I cannot stress enough about the multiple performance test cycles. So you'll need to run multiple performance test cycles in order to ensure that your queries are performing on par with Oracle or better than Oracle. And this is what we have seen with most of the customers, and this is what has worked well for many customers to ensure that you run multiple performance test cycles, because it is possible that after migration the queries are not performing up to your expectation, and then you need to basically iteratively fix them. It is a possibility, so highly recommend to run multiple performance test cycles in order to ensure that you get the performance that you expect after setting the right target skew. And if there is an opportunity, leverage the power of cloud. Like I mentioned about automatic backups, OS updates, patching, high availability, disaster recovery, there is a lot cloud can offer, a lot that Azure can offer. All of these tasks are simplified when you move to cloud. So that is some of the key learnings that we take from customers, how their process is simplified, how they are able to scale up because of cloud, because of Azure. Because what we've seen with the customers is that their operations have become massively simplified because they have chosen a managed service. And coming to data migration, use of tools like Azure Data Factory will help you templatize the data migration to come up with a way to parallelly migrate the data and scale the data migration. You could use this. You could use Data Factory. Data Factory is an ETL, cloud-based ETL tool in Azure, and there are templates available online which you could use to basically load many tables in parallel. One of the cool tools that my customers use to ensure that the data is successfully migrated from source to target is the data comparison tool. And I leave the link to the tool here, and it'll also be there in the description. So the data comparison tool is a tool developed by one of my colleagues. He calls it data comparison tool, simple as that. So what it basically does is it compares data between the source and the target and gives you a report if the data matches between the source and the target. This is very handy when it comes to ensuring the data data integrity checks after migration. I'll share these links in the description. These are a few pointers and important links that would help you in your migration journey. I'll leave them in the description as well, and you will get them in the copy of my presentation. So with that, we have come to the end of the session. Be sure to visit the links that I've shared earlier. And last year in CitusCon, I spoke about migrating partition tables from Oracle to PostgreSQL. In case you are interested in that topic, in case you would like to watch that topic, you can watch it here. That link will appear here, I guess. And I'll also leave it in the description. We've also published a detailed migration guide at docs.migration.com, which also has scripts that you could use in your data migration journey to successfully migrate from Oracle to Postgres. And I'll leave the links in the description as well, and it should appear somewhere here. So feel free to reach out to me in case you have any questions regarding Azure Database for PostgreSQL or Oracle to PostgreSQL migrations. I'll be happy to answer. Send in your questions over email. You can see my email on the screen, or hit me up on LinkedIn. Hope you're enjoying Posette. Thank you for joining.
Well, that was great. With the explosion of popularity of PostgreSQL, we're going to see more and more migrations from Oracle to PostgreSQL, and Adithya provided some customer examples, deep insights, and then shared tools and resources that other people can take advantage of, and even showed us how Flexible Server makes that journey easy and for customers.
And if you're interested in migrations, there was a talk in Livestream 2 about accelerating PLPG-SQL code conversion when migrating to Postgres. So you should check that out when the recordings come out, or watch the Livestream 2 recording, which is available now. Yeah.
Sorry, I advanced the slides too quick. I wanted to remind everyone that we have a Cloud Skill Challenge on Microsoft Learn. about Azure Database for PostgreSQL. There are 2 challenges, and if you complete them by June 24th, then you enter a lottery and win one of these cool prizes. And the link for the challenge is below.
And just make sure and fill out the attendee surveys. Just want to keep reiterating this because the speakers really appreciate it. So make sure and do that. Yep. So up next, we have Pamela Fox. She's a principal cloud advocate for Python developers at Microsoft. And I'm really excited because I love hearing talks given by educators as talented and experienced as Pamela. She's taught computer science at Berkeley and has been a groundbreaking developer advocate, has been doing this for a long time and has a lot of experience. I noticed that she has volunteered with Girls Who Code, one of my favorite organizations, and she actually founded the SF chapter of Girl Develop It. So she's has a lot of experience with developer workshops, growing new developers, and also helping cloud providers like Microsoft make the best tools to support them, which is important that you have that connection with the developer community and make the best tools for them. So today she's going to talk about how to leverage pgvector in your Python web app. It's very timely, so I'm excited to see what she has to say.
Hello, I am Pamela Fox, and I'm talking about pgvector for Python developers. pgvector is a great extension that you can use in order to store vectors in your database and then do distance operations on them. It's incredibly useful if you're doing any sort of similarity search, especially for generative AI applications like retrieval augmented generation in order to search and chat with items in your database. So come to my session to learn more about pgvector for Postgres and Python. Welcome, everyone. I'm going to be talking about pgvector for Python developers, bringing together my 2 favorite things, Python and Postgres, and then my 3rd favorite thing, vector embeddings. So I'm going to start with just an overview of vectors and what I'm even talking about. A vector is a list of numbers. It's a list of floating point numbers typically, and this list of numbers represents an item in a high dimensional space. So here in this graph, I'm showing, vectors that have 3 dimensions, but typically we work with vectors with much, much higher dimensions, and those are just harder to visualize. So, for the string apple, we have an example vector here, and then we could also have a string for oranges, and, the vector, we're trying to compare these 2 vectors. This oranges vector has another set of values here. So you can think of this, we call the list of floating point numbers. It has a length. We also call that its dimensions, because we consider each of those numbers to be a dimension in the space. And the tricky thing is, what do each of these numbers actually represent? A lot of times we don't really know what each of those numbers represents. We just know that there's some sort of dimension they represent of that vector. So we use a model in order to generate a vector for a particular piece of content. So for example, we could take the word dog, and then we pass it through this machine learning model. We could use like a word-to-vec model. That is one way of generating embeddings for single words. And then we get back a vector, and that's the list of floating point numbers. We could do the same thing for other words here. So like cat, and we get back a different list of floating point numbers. Now, there are many models that you can use to generate embeddings. And what matters about the models is what kind of input can you give it? And then how big is the vector that comes out? And what are the characteristics of that vector? So for example, these are some of the most popular models. Word2Vec is a model that we've had for many, many years now, but it only takes a single word. And then the dimensions that come out can be anywhere between like 50 and 300. Now, more recently, we'd have these models come out from OpenAI and from large language models generally that are able to take in large strings of text. And that's made for much more interesting applications. So for example, with OpenAI, it can take in a text of up to 8,192 tokens. And those dimensions vary. One of their models has 1,536 dimensions, and then their newer models actually can vary between 256 and 3072. So you have high variability in how long the text is you can pass in, and then high variability in the actual dimensions that come out. There are also embedding models that can take more than just text. So we, at Azure, they have the computer vision multimodal embedding API that can take a text or an image, and it has dimensions of 1024. Now, there are quite a few other embedding models. Many of them are open source, so you can find them at Hugging Face, and there's even this leaderboard that tries to compare the different models to see how well it does in different data sets. So lots to explore in terms of what models you can use in order to generate vectors. So once we have the models, why do we even care? Why do we want to go through all this effort to turn our data into vector embeddings? Well, once we have data represented at vectors, now we can suddenly do really interesting things. So we can start off with similarity, right? We can say, okay, these two items are more similar in the data set than these two other items. And that can be great for recommendations, for, doing like fraud detection. There's lots of things you can do once you can look at similarity. We can also do search, which means getting an arbitrary new input and turning that into a vector, and then using that vector to find things that are similar to it. And we're going to see how to build both similarity and search algorithms here today. Now, I have some tools to help me understand vectors. So here's one where I visualize vectors across a few models. So we have Word2Vec versus OpenAI. And so you can see with Word2Vec, our vector has 300 dimensions. With OpenAI, it has a whole lot more. And what I've also shown here is just within this particular word set of 1,000 words, what are the most similar words to this input, right? Because they're talking about being able to do similarity algorithms. So for dog, the most similar one is cat for Word2Vec, which makes sense. For OpenAI, it's God, which is interesting. And what you can see here is that different models encode different things in their vector space, right? So Word2Vec is, you could say, almost like purely a semantic space where it cares about the semantics of words and how they show up next to other words in different contexts. So dog and cat are so incredibly similar because they're both pets. Cats are better, but they're both pets. OpenAI also tends to encode things about the syntax and the spelling as well. And so that's why we see that God is the most similar to dog in this list. So I find this really interesting just to get an idea for the fact that, within different vector spaces, you're going to have different results when you're doing similarity and when you're doing search. You can also look at, what is the least similar, and you can also kind of see the range of, how the similarity distances. And this is the way we're, calculating this. So that's one way that I try and understand vectors. Another really fun tool is this from projector.tensorflow.org. And this tries to visualize these vectors in three-dimensional space using a principal component analysis to reduce the, very large vectors into just 3 dimensions. And, it does a pretty good job. Now, it's really, really hard to reduce, these very high dimensional vectors into much lower dimensions and really be able to represent all the complexity of what's encoded in their space. But it's pretty fun to look around and visualize and see what's most similar to IP is TCP and routing. That's great. Analog, magazine, highways, road. So this is just another way to get yourself accustomed to thinking about vector spaces. But remember, it's much more complex than we can ever visualize in 3D. So how do we actually measure the distance between two different vectors, right? We need to be able to measure distance if we're going to do any sort of similarity or search. And there's a number of different distance metrics. And, these are all actually supported by Postgres. So the first is Manhattan distance, also known as taxi cab or L1. And it's known as taxi cab because it's literally like if you have one location and another location in a city, what are the streets that a taxi would have to go down? Or like in this grid here, what are, it has to travel along the grid. How does it have to travel in order to get from the end of V1 to the end of V2? So we can see for this, for these two vectors, 1, 2, 3, and 3, 1, 2 in this three-dimensional space, the Manhattan distance is 4. There's also Euclidean distance, which is the straight line distance, right? The as the bird flies. And, typically we would use this over Manhattan. This is known as L2 distance as well. Now, a more interesting one is the dot product. It's called the inner product, the dot product. It has a few different names. And this is, it's actually like projecting one vector onto the other and then figuring out the area between them based on the angle. And it ends up producing actually a scalar value, this number. So for these ones, it produces a value 11. And that's the way we can think about, how close these two vectors are. A variant of this is cosine distance, where cosine distance, we care about the angle between these. And these two are actually the same if your vectors are normalized. And as it turns out, many vectors are normalized, as in their unit vectors. So if your vectors are normalized, these are the same, and the dot product is actually the more efficient one. Okay, so though that is our Vectors 101, you can get way deeper into that if you're interested. Lots of great resources out there on the web. Now let's talk about how we store vectors in Postgres. The first step is to use the pgvector extension, and there is a great GitHub repo where you can get the instructions for how to install it. So I've got it installed locally here in a VS Code environment here, and I've actually got it installed inside a dev container, which is basically like a Dockerized development environment. So I set it up using a docker compose.yaml so that I could bring in pgvector. And so here I have the very latest one because I wanted to get this new operator they just added. And yeah, so that sets up a Postgres server that is running inside my container. And you can see that it's running here on port 5432, which is the default. So I've got that running inside my environment here. And that's gonna, make it so that I can use the extension. But then the first thing you need to do after you have the capability of using the extension is to actually run this create extension command here on whatever database you want to, use it with. So we'll go back to here, and I'm going to use my SQL tools extension in order to run SQL. So I'll just run this, and boom, it worked. No results, but it worked. So that's good. That meant it knew how to make the extension. Now, notably, the extension is called vector, not pgvector, which is actually, I think, the most confusing part of pgvector is that the extension is called vector. All right, so now we've got that extension. Now we should be able to actually use it. So what we can do here is first we can create a table that has a vector column. So this is a new type that's introduced by the vector extension. And we tell it, okay, we want it to be a vector column and we want it to be 3 dimensions long. So we're going to start with just our, our small vectors. So let me run that. First, let me actually drop it because I bet you it already exists. Let's see. Okay, dropped it. And now I'm going to make it. All right. And the next step, we're going to insert some vectors into the table. And so here I'm specifying the vectors using an array inside quotes. That's one way we can pass them in. So I inserted them. Now, do they exist? I can actually just use SQL tools and check out the table and see that, yep, we do have 2 rows and they're storing vectors. Now we can start querying. So we can use the select. Let's do this one. So this one does a select from items, order by the embedding column. Remember this embedding column? It's distance from 312. So we're curious about how, what are the closest vectors to 312? And then it'll get the top 5. So let's run this. And here we can see that it thinks that this one here, 456, is the closest one. We can also ask explicitly what is the distance between them, right? So the way we did, do this one is we're actually going to put that expression in the select. So we have select, embedding, distance from, so this is the distance operator we're using here, distance from this target vector, going to alias it to distance and get it from the items table. So we'll run that. And what we can see is that the distance for the first one is 214 and the other one is 116. Okay, so we've been able to store items, we've been able to query, and we've done this all with just pure SQL statements. And they're all working, which is great. Now, you saw that I was using this operator here. This is one of the distance operators. This is actually that's the cosine distance operator, but we've got 4 different options. So the same distance things I showed before, we can do all of that in Postgres with a pgvector extension. So we could do Manhattan, right? So we could go and change this to Manhattan, and we can see 4 is the answer there, right? We could do the dot product as well. And we can see -11 and -29. So this one's actually the negative dot product, just because of a detail of how pgvector implements this. They take the dot product and then they negate it. We did the cosine distance already. We can do Euclidean, and then something interesting is actually going to happen. Oh, actually Euclidean worked this time. Okay. Sometimes you may get an error because this operator is also used by Postgres for other things. So sometimes it has a hard time telling when you're trying to use this operator for vectors versus other things, like if you have the PostGIS extension. So if all else fails, you can also use the function. You could do, L2 distance, embedding, and then our other vector, and run this. And we get the same results. So you might be wondering which of these distance operators to use. Generally, the one I would recommend is the dot product, especially if you're working with OpenAI embeddings, which is what many people are working with these days. Then I would recommend the dot product. Lots of people are recommending cosine distance, but in fact, the dot product would be more efficient because it's actually the cosine distance is, you need that if you've got non-unit vectors, but if you're working with normalized vectors, you can use dot product and it's more efficient. So that's what I would tend to recommend. But generally, you can just look up for the model and say, okay, for this model, what distance operator should I be using? And you can also, do some comparisons in terms of time and accuracy and all that. Now, I've only shown you, these really small tables. We could potentially be storing thousands, millions of vectors in our table. How do we do these queries in a fast way? So we generally are going to want to add an index that can do an approximate nearest neighbor search. The most popular index these days, it's HNSW, which stands for Hierarchical Navigable Small World. So we can do this create index command that will tell it like, hey, we want you to create an index using HNSW. And we tell it, here's the column for the index. And here is the operator you're going to use. So in this case, we're using inner product. Because remember, I just said that's what I would recommend, especially for the OpenAI embeddings. So we can run that, and that creates an index. There's a lot more configuration you can do for an HNSW. So if you're curious about HNSW, there's a great tutorial here. There's great videos online with more information about the different parameters for HNSW. Because generally, they're going to affect your precision, your recall, your speed, and you have to figure out what's going to work for you because this is an approximate nearest neighbor search. So as soon as you start using approximations, you do risk accuracy. So you do want to consider that in terms of what index you use. There is one other option you can use with pgvector, which is IBF flat. I haven't actually personally used that myself because I always use HNSW, but it's another option, and there might be some situations where it is the better option. All right, so finally, let's talk about pgvector with Python. So once you understand how to just use pgvector with Postgres, using it with Python is actually, I think, fairly straightforward. You can install this pgvector Python package, and it's built by the same people who create the pgvector extension. So it works really, really well with it. And it comes built in with support for all of the best Python packages. So PsychoPG, Async PG, SQL Alchemy, Django, all the ORMs you would think about using. And it has great examples in the repo. So let's go ahead and check out some of those examples here. So in this environment here, I have a bunch of the examples from that repo, right? So here is with PsychoPG, that's just running all the stuff that we ran in the SQL tools. We could run this, go to the terminal, right? But what's more interesting is using an ORM, because if we're using it from Python, we probably do want to use an ORM. My favorite is the SQL Alchemy ORM, right? So in that ORM, I can declare my my rows using Python classes, and I can say, okay, I'm using vector, and that vector class comes from the pgvector Python package. So I say, okay, I'm using vector, and it's got 3, and then, I'm going to create this index, and here's these additional options I was telling you about, like EF construction. Then I add my items, and then, I'm doing some distance operations here. And I get the same results, except I did it with an ORM. Now, a more, interesting example, this one is with movies. And what I did is I took movie titles and I embedded them using the OpenAI embedding models. So this time I have a vector of 1536 dimensions. And I've got a bit more data than I had before. Still not a huge amount, but a little bit more. So I'm going to run this one. And it's going to try and find the most similar movies for Winnie the Pooh. And it's just based on the embedding of the title, not of the description or anything like that, just the title. So here we can see the most similar ones in Winnie the Pooh are other Pooh movies, which makes sense. And then also Pinocchio, which makes sense because it's a toy come to life. And then Alice in Wonderland, once again, toys come to life. So it's really, really interesting when you start to, play with these embedding spaces to see what it thinks is most similar for a particular input, right? And this is just based on the titles. If I did the entire movie description, we would see much different output, right? For Frozen, all the most similar things are actually related to like water and cold, because Frozen, it doesn't think of that as a Disney movie. It just thinks of that as the word frozen in this particular embedding space. So really, really interesting. Okay, so we've got, these are some examples where we can see how we can work with SQL Alchemy. Now let's actually use this for a full app. So going here, I have a fast API app. So this is, one of the most popular ways of building APIs in Python. And I can show you the fast API app here. This is the auto-generated documentation. So we've got operations for getting an item by ID, for getting the most similar items to something, and then for searching. So let's try if we get an item by ID. This is just doing our, a standard SQL call. And so we see this is a database about camping gear and like recreational gear from a store. So we get back these boots. And now if I want to do most similar, I'm going to say, okay, get me the most similar items to item 1. And I execute that. And I see what I get back is a bunch of boots and shoes. So let me show the code for that. So in this fast API app here, we can see this is a similarity handler. And what you can notice is that I am using async. Since this is fast API, we want to be able to use async. This is going to enable better concurrency once we go live to production with users. So general tip is to always use async, and you can use SQL Alchemy with async. So that's what I'm doing. I get the item by ID, and then I do the same operation that I've been showing all along, which is, let's get the item, let's get the distance from the item, let's exclude the current item, and then order by the distance. And then I return the item's dictionary plus the distance so that when we look at the results, we can see, okay, here's the matching items, and here's how similar we thought they were. And then finally, we can do search. So with search, I can input an arbitrary new string, right? So I could do boots, right? And if I do boots, then I get back the things that matches boots. And it's doing both a vector search and a text search, combined together. So we get back lots of boots. I could also search in Spanish because it's going to work because of the vector search. So Spanish gets back boots as well. I could even be like really like colorless footwear, right? These are words that don't appear in my descriptions at all. But if I search colorless footwear, I get great results. I get gray trail shoes. I get clear hiking shoes. And I get black hiking shoes, colorless footwear. So this is the great thing about vector search and vector embedding spaces, is that then a user can type in, other languages. They can type in, strange, obscure descriptions like colorless footwear, and you can still get a match. If I disable vector search here and then I search for colorless footwear, I get no results at all. So this is really, really powerful. So let's take a look at how this is actually implemented. So here's our search handler. So let's go here. So the first thing we do is that we turn the input query into a vector. And then we use that to do a SQL query. So this is doing a combination of a vector query using pgvector. So this is the vector query. This is doing a full text query using Postgres full text search capabilities, built-in capabilities. And this is using, the text version of the query. So this is using the vector version of the query. This is using the text version of the query. And then we combine them together and we merge them together. We compute a final score using this algorithm called reciprocal rank fusion. And that gets us the merged results. And then we can return back those merged results. So this is what's known as a hybrid search. And this is the best practice for how you can take a user query and search a database and get back the best results. If you use both vector search and full text search, which we can do in Postgres very well, then we can get these amazing results here. So there we go. That is how we can, build many very useful and powerful APIs using pgvector in Python. All of the code that I've showed you is open source, and you can go and check it out. And you can find even more examples in the pgvector Python repo. So I definitely recommend checking that one out as well. And you can get my slides from this URL here. So if you want to follow any of the links that I showed, just go to the slides and follow the links from there. And I'm, happy to take any follow-up questions online over, all the different networks, and just hear, how people are using Postgres with pgvector and learn more from all of you. I've only learned it in the last year, and it's been great to see all the resources that are there. And I'm trying to put more resources out there in the world based off of what I've learned about using it. So thank you.
That was great. So in 25 minutes, we got introduction to vectors, introduction to pgvector, and then Pamela showed us how to use that in Python and Django. I also think this is such an exciting topic because since last year, everyone has so many developers, so many app developers have been learning about vectors in order to implement copilots, chatbots, recommendation systems. So this is kind of the year, or maybe it'll be the decade of the vector. So thank you, Pamela. Let's see. So on this topic, I should say there are 7 AI-related talks in this in the conference. So please check out the others. In fact, later in this live stream, Denzil will be talking to us about AI as well.
So again, in the Discord channel, the speakers have been answering questions. So keep asking your questions in the Discord channel, PosetteConf. And reminder to continue live posting. The speakers really appreciate it. And you can use the hashtag on any platform where you're active. So we're going to see a little bit of what's up next. The live stream 4 starts, in 10 hours to 15 hours. I'm not sure. But in the EMEA time zone. And so we're going to take a look at what's in store for us then.
My name is Thomas Munro, and I'm going to be talking to you about the Postgres project, or PostgreSQL, where it came from, what sorts of things it does, how it is made today, who makes it, and a bit about how I myself got involved in it, and how you might get involved in it if that's something that you're interested in, or if not, how you might use it.
If you're planning to partition more than a single table in your Postgres environment, this is the talk you have to see, because if you partition multiple tables, you have only one chance to do it right, and this talk gives you all the information you need to do to build a great environment, which is really fast forever and ever. So, welcome to Partition Your Tables for 20 times better performance.
So hi, my name is Tomáš Vondra. I do work for EDB. I'm a long-term contributor, developer, and also a committer. And I'm here to talk about performance cliffs, which is a performance issue affecting a lot of people that may not be aware of that. I'm going to explain how the performance issue actually happens and why.
I am a senior software engineer in a team which is responsible for internal database as a service platform. And today I want to share with you our findings and experience when adopting and supporting our internal CDC solution based on logical decoding.
Hello everyone, my name is Hans-Jürgen Schönig. I'm the CEO of Cybertech, and hopefully for this year's conference I've prepared some really interesting performance stuff you've never seen before. So if you're seriously interested in performance, check out this talk and learn something that is way beyond just adjusting some Postgres configuration parameters. Have fun.
Hi everybody, I'm Luigi Nardi. I'm the founder and CEO of DBTune. Very excited to be here at Posette. Today we'll be talking about auto-tuning Postgres. So if you are interested in learning about the configuration of your Postgres instance to achieve high performance, this may be the talk for you.
Hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and I'm speaking at Posette about why you don't need a database backup policy. You're probably wondering why. As a DBA of over 20 years, I'd be telling you that you don't need a database backup policy. So hopefully this talk's going to be interesting to anybody who has data that they care about and want to keep safe.
Hello everyone, my name is Taras Kleban. I am Senior Solution Architect at Microsoft, and today I want to present a solution which we created for a tight NATO hackathon to advance drug search, and also show how we utilize for this Postgres and the Azure AI extension.
Hello everybody, my name is Federico Campoli. I am a freelance PostgreSQL consultant, and today I will talk about PostgreSQL running on top of ZFS, a powerful file system, but with a bad reputation. So if you are a sysadmin or DBA and you are searching for an alternative for performance and scaling up your system, you may be interested in my presentation. Thank you.
Hi everyone, I'm Paolo Mecchiore. I'm the CTO of 20Tab, and I'm a member of the Django Software Foundation. I use Django since a long time to do my web project, and today we'll see together how to integrate semantic search using Postgres and pgvector.
What a lineup. Very exciting. And now we'd like to go ahead, Melanie.
I was just going to say that just a reminder that you can get your swag at aka.ms/Posette swag, and the code's right there at the bottom. You need them.
And now we're going to have a talk by Grant Fritchey. Sorry, did I lose? I
think we actually are back. So.
Oh, I'm sorry. I
go back to KK and Melih are going to talk next.
Yes,
I'll talk about what they're going to talk
correcting.
about, and you retreat the slides. Okay.
Yeah.
Yes.
Okay.
So,
Thank you.
KK and Melih are both on my team, so I'll make sure that we don't skip them.
All right, very good. So I'll introduce KK to start. KK is a colleague of mine, full name Krishnakumar Ravi, but we'll call him KK. And KK actually was co-host as well in the first Livestream 1. And so an engineering manager at Microsoft. He leads Microsoft's team of PostgreSQL committers and contributors. He has 20 years of industry experience and has worked in diverse tech, like porting Linux to embedded boards in electric networks, high-performance computing, scalable file systems, and storage, and Kubernetes. He's been working in the Azure PostgreSQL group since 2020.
And he's giving this talk with Melih Mutlu, who's an engineer on my team, working on a hacker working on upstream open source Postgres. And he's worked on a lot of exciting features and really on a broad range of topics. They're talking about physical replication today, which he's worked on. He's also worked on memory management and even libpq performance optimization. So he's really gotten a big exposure to a lot of areas and a lot of subsystems. You should ask him all your questions about any part of Postgres. But today they're going to be talking about physical replication. And I'm excited for this talk because I know personally, just trying to review actually one of Melih's patches from last year on physical replication, trying to learn the internals is pretty difficult, and there's a lot of moving pieces because you have multiple Postgres instances or nodes, and so just being able to have someone explain it to you and sort of do the boxes and lines on a whiteboard is invaluable. So I'm super excited for this talk.
Hi, I'm Melih.
Hey, I'm Krishnakumar. You can call me KK. We are here today to walk you through a presentation on PostgreSQL physical replication, the internals of this, recent developments, and what sort of future work can be done around physical replication.
So, hi again, I'm Melih. I'm working at Microsoft as a software engineer. So my current team is the open source Postgres team, where I and rest of my team are working to contribute the open source Postgres. So I spent the last 2 years working on mostly replication, started with logical replication. Then in the past year, I'm more focused on the physical replication, trying to learn how it works. So far, I also given talks about my experiences, how I got started with Postgres and how to contribute it. And previously again at Microsoft, I worked on different teams, but they were all again with Postgres. So I did some work for Azure database for PostgreSQL, and I worked with Citus team in the past. So yeah. A brief introduction of myself.
Cool. I'm KK. I'm engineering manager for Postgres open source contributors and Postgres engine team. Started with Linux porting to new boards and device drivers. Worked in a company called NatureSoft for a while. Moved to HP. Did more high performance computing style stuff, and worked on a startup of hybrid cloud storage called StoreSimple, which got acquired by Microsoft and then came to Microsoft. The most exciting part of my job nowadays is interacting with PostgreSQL folks, the top folks who contribute a large amount of features into PostgreSQL as part of our committers and contributors team. Today, we are bringing you some of the learnings from those interactions, as well as our own experiences with physical replication. And let's get going. So, from a start point of view, let's just talk a bit of terminology. So, the first thing which kind of confuses everybody is what's the difference between physical replication and logical replication. It took me a while to get it when I was beginning with PostgreSQL, but just to give a quick overview, Postgres deals with everything in terms of WAL records, in the sense that whenever there is a change made into the database, that will end up with either like a single vault record, like a multiple set of vault records that are there. In case of physical replication, these vault records is what gets transmitted between, let's say, a primary primary Postgres instance and a standby Postgres instance. Between them, these vault records get transmitted, and primary, whenever changes go into primary, the vault records get to standby, and in standby also these changes are made as well. So that's the high-level view of the physical replication side of things. Then comes the logical replication, where it's actually the SQL statement itself, which is like converted and like communicated and replicated, which is like quite different from the physical replication case where vault records are directly communicated. Now, in both physical replication as well as logical replication, the presence of endpoints, as in like we have a primary, we have standby one, and maybe we have a read replica, which is also consuming this primary's data. All of them are represented in terms of slots. So for physical replication, logical replication, there will be slots, which is the concept where in the software of Postgres, it's equivalent to, there is another endpoint which is replicating from this source that is there. So that's the slot concept, a representation of the endpoints. The other few terms which we'll quickly go through is like, what is synchronous replication and what is asynchronous replication? In terms of synchronous replication, think of this as if you have a transaction come into the primary, until it gets reflected on the standby or the set of standbys that is chosen for the quorum, until then the transaction is not considered successful. So as you can imagine, this is a feature, right? Like where synchronous replication can be used for something like high availability, where there's a primary and a standby. And when the standby has some issues and it goes down, when the primary has some issues and it goes down, the standby can really pick it up. So that's one place where synchronous replication gets used. There are many other places where this gets used as well. But because synchronous replication does not have the challenges that the data is not like lost every time you are committing on the primary, it's also guaranteed that standby will have it. Because of this, we can use it for a scenario like HA. Coming to something like asynchronous replication, where there is no guarantee that when you commit locally, it is also committed in the remote scenario, where like when primary commits a transaction, it doesn't mean standby is already caught up with it. It will eventually catch up depending on the performance of the network and a lot of other factors coming to picture. But these scenarios can be used in cases like, let's say, read replica, where you are not really looking for exact data to be available, and you can wait for the data to come in. But at the same time, you do want to have the communication between the primary and standby, and making sure that whatever goes into primary eventually ends up in the standby as well. And you can run queries which will be analytical and other sort of queries. So that's where one scenario where asynchronous replication can be used as well. GRDR, and there's a bunch of these scenarios where it gets used, but conceptually, synchronous means that we have persisted and made sure that primary and standby are in sync, and then async means it can take time as well. Quickly, we will talk a bit on the streaming part of this. So when it comes to physical replication, you can actually have other scenarios where you copy the vault records onto the standby and make the standby recover from those vault records. But in case of streaming replication, there is a full-on connection between the primary and standby, and the vaults are streamed from primary to standby. So it is a consistent connection that goes on, and we'll go into details of that in the presentation. In the context of this talk, we will be talking about physical replication and synchronous and streaming replication in pictures. So physical streaming, synchronous replication is what we will primarily focus on. So here is just a setup. So we'll go into the details of how this works, but primarily we will just quickly look at what is there when we try to do some of these physical replication setups. So here is in the screenshot, what we show is primary on the top, it is output from the primary PSQL connection, and the bottom we have standby logs. So you will see the arrow which points to the points from the top to the logs. That indicates that primary is at a certain LSN number, like the DA0 number. That is what is currently there on the standby as well, right? All of the LSNs like sending, flush, and apply are all consistent, and it is there in the primary as the current LSN that is being operated on. When we do an operation like create table, that's what is shown in the next set of operations. So when a create table happens, obviously the LSN moves forward in the primary. But when you look at the logs, what you can see initially is that the logs start with the LSNs not fully caught up, but eventually by the time the table transaction goes to the standby, you will start to see the LSN match there as well, which is the new LSN which has been created, the vault record which has been created on the primary. So this is a demonstration of how the physical replication setup happens, and how they can come. You can look at the logs and kind of see what kind of movements happen with respect to LSN. So that's basically the intro and the logging comparison that we have. Let's move to the next. Go ahead, Miss.
So yeah, thanks, KK. So let's dive deeper into how physical replication on Postgres works. So this is a simple overview of components that make the physical replication happen. So you see that the flow kind of is from left to right, and it starts with your application, and application connects to the Postgres backend process. So at this point, like KK mentioned, the replication heavily relies on WAL files, like WAL data, so that there are many different processes in Postgres that can generate WALs, and the user backend process is one of those, and there are WAL writer and checkpointer. All of those can write WAL into WAL buffers, and eventually those WAL data in the buffers needs to be flushed to WAL files, to the disk as WAL files or WAL segments, to ensure reliability in the cluster. And when you set up the replication, there are two important processes. One is WAL sender, the other is the WAL receiver. WAL sender is on primary, that is responsible for sending WAL data from primary to standby. And on the standby side, the WAL receiver is the one that communicates with the primary, and it just receives WAL data from primary and then writes into standby's disk. So let's move on with how this WAL generation works first. So this is our primary setup. We have application already connected to Postgres, and we have buffered some files ready there. So first thing, as a user, I start my transaction by running begin, and begin command just puts inserts a WAL record into WAL buffers. So it basically generates a WAL data, and in this case, its LSN is 0. So you can see that the WAL buffer has an LSN 0 record, and you can also see that there's already a WAL 0 file from before. And then I move on with my transaction and just keep running some more statements, and since I keep running the query, Postgres keeps inserting the WAL records into WAL buffers. You can see we have now LSM 1, but still we don't have any new WAL files yet. So eventually I will run commit to end transaction, And the commit itself also will insert a wall record, the LSN2 here. And like when, like just before transaction ends, the commit statement also triggers Postgres to flush wall buffers from wall records, like wall data from wall buffers to wall files to make them persisted on disk. So you can see that after running commit, we now have a new additional wall file, wall1 in this case. So this is how running a query can generate a wall file on your server. And when we move to the replication side, now standby server comes into picture here. So again, initially we have all the processes we need, and we started the replication, and like initially standby tries to connect to primary, so it sends a connection request, and when the like Postgres backend receives that connection request, it will immediately launch a wall sender process. Until a standby tries to connect to primary, there will be no wall sender process on your server. But when the standby is there, wall sender should be there too, so it will launch the process. And then standby will start communicate with the wall sender by its own wall receiver process. So wall receiver will send its standby's latest LSN to primary, so that wall sender can decide, which wall data should be sent to standby. So after getting the LSN, what wall sender will do is simply reading wall from disk. It will just read necessary wall data and will try to send to standby. And on the standby side, wall receiver is the one who is receiving this incoming wall data. And after getting the data, the wall receiver will directly write wall data into disk as wall files without attempting to write anything into wall buffers. And eventually, since this wall data on standby needs to be applied to make standby and primary in sync, at this point you see that we now have missing wall files on standby right now, wall 0 and wall 1. So the startup process is the one that reads these wall files and simply just applies those wall data to apply those changes into standby server as well, so that the primary and standby will be in sync. So this was like how replication works in a nutshell, but it's a feature that keeps improving with every release. So I just want to mention some few recent works about replication. First one is the reading wall directly from wall buffers. This feature will hopefully come with PG17, and it will. So as you remember, I just mentioned that the wall sender reads wall data from directly disk without looking into wall buffers. This feature makes wall sender to look into wall buffers first, and then if data does not exist there, then it can look into the disk. So, and the next things, of course, like there are many bug fixes. Like one of the interesting bug fixes that fixed in version 16 was standby servers, like startup process on a standby server was crashing. It's by saying cannot allocate any memory when the primary server is not available. So this is one of those bugs that fixed in the last couple of releases, for example. And the last thing is this, like allowing the wall processing to prefetch data beforehand. So this is actually is there since the version 15. So it's a feature that prefetches wall data before you actually need those data. So like Postgres can somehow know or predict that you will need those wall data at some point. So it prefetches beforehand so that when you need those data, it will be faster to read and use those walls.
So coming to the opportunities that lay in front of us, right? Like, so as Melih was explaining, physical replication is an evolving area. A lot of work has gone in till now, but a lot of work remains in front of us as well. And here are a few things that we have picked up from the community, from discussions that we have had and things like that. And the idea is that these opportunities provide inspiration to folks who want to work on physical replication, as well as come together and contribute and make Postgres even go to higher heights than it's already there. So here specifically, as Melih was saying, on the primary, we do have in PG17 a feature which will make sure that we are no longer going to the wall files to read when the walls are sent across. But if you go back to the slides that we had in the beginning, where we talk about the standby, how it persists the wall record after getting from the primary, there is a place where we could do the similar thing on the standby as well. And that's one area which could use some contributions where we read directly from the wall buffer. And then thereby avoid file operations when on the hot path that is there. The second part of this is that every time, the second item that we would like to talk about is that like every time we have to send a wall record, we also have to wait till the wall is flushed in the primary. Until that is done, we don't send it to the standby. This is done for primarily because of correctness and consistency perspective. But if we get to a place where we can modify the communication between primary and standby to send the wall even before it is fully flushed, but the standby does not apply these walls, but does all the pre-processing required before the wall is applied, like maybe checksum checks and other things are already done and it's just waiting to apply. This can introduce scenarios where specifically, let's say, cloud network disk kind of thing. Nowadays, like there's no like direct disk in most cases. It is all managed disk that gets used, where there is some sort of network in between. And this serialization currently prevents us from capitalizing the scenarios where we can parallelly send it across the network, like via the disk drivers and things like that. But like don't wait for the local flush to happen. So if we have a feature where this is decoupled, the serialization is decoupled, and we have some sort of protocol modification, then we will improve a lot on the latencies that we have with respect to physical replication. The other part of this is that right now when on standby, we are doing the wall flushes, and then we are prefetching these walls and applying in the standby. But whereas if we really just do the wall writes and then indicate that we are almost ready, but don't apply, we will again like be able to do the pre-processing parts of these operations, thereby improving some of the resource usage on the standby and performance. Other idea is that right now the communication between the primary and standby is typical network communication. In Linux, we have this IOU ring functionality which has come in. It's revolutionized a lot of networking and storage, operations. So could we bring IOU ring into the networking area in Postgres and thereby evolve to a place where the communication channel between the primary and the standby takes benefit of this? So that's another thought that we have, which we want to put out to invite more collaboration and contributions. So that's those are those opportunities. So thank you for listening in to the talk. As is the case with any talk, there's a lot of people supporting this talk to make the final thing happening. We'd like to thank the Microsoft committers and contributors team. Special thanks to Thomas and Anders, because a lot of this has come from offline discussions with them. But all of the team has contributed to these. Thank you for Posette organizing community, as well as PostgreSQL community for all the great work on which we are all greatly standing on the shoulders. Thank you.
Yeah. Thanks, everyone.
That was great. I really appreciate the flow chart or the diagram that had the step-by-step sort of, then the which process connects from the, primary to the standby. And I think that's super helpful for me. Like when I'm learning about a new subsystem, I basically draw that myself. So it was really helpful to have that.
Yeah. Quick reminder, please fill out surveys and give feedback. And we're still giving out swag. I think the codes will flash on the screen. There they are. And now, this time for real, I'm going to introduce Grant Fritchey. Grant is a product advocate at Redgate Software. He has over 30 years of experience in IT, and he's an expert on SQL Server and PostgreSQL, as well as multiple clouds, AWS and Microsoft Data Platform. He's written books, lots of books on query performance tuning, on both these databases, execution plans, performance indexing, team-based development, database administration, and best practices. Today, Grant is going to tell us about Postgres performance tuning using the Azure Query Store.
Hello, my name is Grant Fritchey. Today, I'm going to talk to you about using Query Store to understand performance inside your PostgreSQL database. Now, this is really important because unless you know what's happening inside your database and you know how your queries are behaving, tuning those queries and getting them to run fast is going to be really difficult. But Query Store inside of your Azure Postgres database will absolutely help you get it done. Come to the session, find out how. But if you've got questions after today, I would love to help out. And so here's my contact information. Reach out to me. Let me know what I can do to answer any questions that you have. You can get in touch. Thanks a lot. Now, let's get going on the technical stuff. So, query tuning. Query tuning is, what's a good way to put it? Hard. Query tuning is quite hard. You've got to go through a lot of stuff. You want to identify the query that's badly behaving. You want to look at the explain plan to understand what's happening. You maybe have to look at the code to see what's going on there. You've got to do some experimentation to see if you can fix it. Is updating statistics going to help? And what you got to run the vacuum again. What's going on? All kinds of stuff. It's very, very difficult. And then you release it to production. It fixes things. Maybe it does, maybe it doesn't. But after you've released it, then you've got to identify the next badly performing query. And so it always kind of comes back to our start point. Which queries are we going to focus on? That's really the question. That's the big, big question. And so what we want is to have a proactive way to track down these queries, because the last thing you want to do is try to figure out queries just based on, well, I don't know, that one might be slow, or oh, somebody called me yesterday, there was a query that was slow, or the boss, has queries that run slow, so I'm going to go focus on the boss's queries. We really want to get proactive, understand what's happening on our system, understand the queries that are running slow, and then focus on those queries to tune them. Now, before we get going, though, let's talk about a couple of notes on the whole idea of query tuning. Now, the most vital thing, we need to have 2 points of comparison. Without 2 points of comparison, you can't start doing query tuning. So when someone comes up to you and goes, hey, that query ran in 15 milliseconds, it's slow. Well, slow compared to what, right? Slow compared to what they want. Slow, was yesterday it ran in 5 seconds and today it's running in 15, right? We need to know a comparison point. We need to have a before and an after. Before we made a code change and after we made the code change. Before we ran vacuum, after we ran vacuum. Before we added an index, after we added an index. All of these things directly impact performance, but you have to be able to have 2 points of comparison. Otherwise, you're just guessing. And guessing is not how we're going to get this job done. We have to have those comparison points. So those are the two most important things. Next, metrics. Use all the metrics. Are we going to focus on duration? Sure. We're going to spend time looking at duration because, hey, that's an easy measure for performance. Well, yesterday it ran in 5 milliseconds. Today it ran in 5 seconds. Well, I mean, do we need to worry about other metrics? Probably not. But the fact is that you are going to want to make sure you focus on those other metrics. For example, you may have a system that's memory locked, and spending a lot of time worrying about duration may or may not help you. Maybe you need to be focused more on memory metrics and seeing how much memory a given query uses. And remember that any given query may use a lot of memory. It may run fast, so its duration may be very low, but it uses a ton of memory and affects other queries, causing them to run slow because they're memory starved. So you've got to look at that. Same thing with CPU, same thing with I/O. You don't want to get locked on any one metric. You want to make sure you're using all the metrics. Oh, and most importantly, in terms of those metrics, you really do want to focus on execution count. Now, I had a friend, wasn't me. I really wish this was the story about me saving the day, but I had a friend who saved the day. We had a query that was running at about 3 milliseconds. We tuned it, and it was running pretty good. But it was called thousands of times in a minute. And my friend spotted potential fix for that query that got it to run about 30% faster. We went from 3 milliseconds to 2 milliseconds. Now, you could think like, well, 30% improvement, who cares? But when you talk about thousands of executions all day long, we could see it on the system. So focusing on that execution count is really important. Now, next up, we do want to talk about explain plans. We're going to look at an explain plan today. But the thing is about explain plans, we got to be real clear on explain plans. They are an explanation of behavior. They are not themselves a measure of performance. And so you don't want to start looking at plans and saying, oh, poor performance, and let me improve the plan. No, 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 no. Yeah, the plan may suggest that you're missing an index. The plan may let us know that our statistics are out of date. Certainly, the plan is going to give us that kind of information. And then adding an index, getting statistics updated, sure, that may change the plan. But that plan is not a measure of performance. It's an explanation. I mean, it's in the word. It's an explanation of the choices made by the optimizer. And that will help you drive tuning, but it is not itself a performance measure. And then finally, don't forget execution count. Yeah, I know, I already mentioned that one. I mentioned it twice because it's actually very important. The number of times something gets executed frequently has as much or bigger impact as what it is doing when it gets executed. So keep that in mind. Keep an eye on that execution count in addition to measuring, performance and all that fun stuff. Cool. We're level set on query tuning. Let's move forward. Now, we want to talk about query metrics in PostgreSQL. Obviously, we're talking pgstats, right? pgstat tables, pgstat indexes, and heck, pgstat statements. Give me the query information I needed, right? Because that's how we're going to start making those determinations. Which query is slow? Which one do we need to work on? But there's a bit of an issue here. These metrics, as displayed within Postgres, are aggregated. So what's that mean? Well, it means that we don't get 2 points of comparison unless we ourselves do it. If you want to set up something so that you capture pgstat statements yesterday and then capture pgstat statements today, then you've got 2 comparison points and you've got some understanding of what's going on inside that query. Cool. But you've got to build that. And maybe daily is not granular enough. You may need a more granular view. So that's going to be tough. Now you've got to build that in. You got to capture all that stuff. You've got to find ways to put it together. You got to find ways to show it up on the screen. You got to, I mean, there's a bunch of work there. What if you could do it a whole lot simpler? So let's talk about the query store. The query store gives you three pieces of information: query statistics, weight statistics, and explain plans. Now, the query statistics gets you is the standard kind of stuff you'd want to see: query duration, averages, maxes, all that fun stuff. But what they do is yes, it is aggregated. Why? Why aggregated? Why not granular? Why not, every single statement? Well, because 99% of the time, 9 times out of 10, that'd be 90%. Regardless, you get the idea. Most of the time, most people in most situations only need aggregate information. But we do need, remember, 2 points of data. Well, Query Store takes that aggregate information it gathers on the queries, all the query metrics, this query ran this fast, all that fun stuff, and then breaks it up into hour-long segments, giving us that one thing that we really, really need: a before and after. What did it look like yesterday, and what did it look like today? So we've got that final measure that we need, 2 points of data. That's huge. Now, it also gives us explain plans. And the explain plans it captures multiple explain plans. So if there was a different explain plan yesterday for the same query than the explain plan for today, we've got the ability to compare those two explain plans and then understand, why did performance degrade overnight? Did the vacuum didn't run? We had some other problem. Something's gone wrong with statistics. Who knows what it is? But having those two explain plans means we can make the comparison that we need to make to understand what's going on our systems. This is a win. Now, it may be that you come in, you look, and you see the explain, it slowed down overnight. You look at yesterday's explain plan, you look at today's explain plan, and they're the same. Well, we've also got the weight statistics, so you can see why things were slowing down in weights, because maybe you're getting blocked by another process. Maybe there's a problem on a server setting or something, and we need to make some adjustments. Well, we can see the weight statistics as well. So we've got all of that information, all of it broken down so that the aggregates, while there are aggregates, those aggregates are broken up into pieces, giving us multiple data points so we can make the comparisons that we need to make in order to do query tuning. Cool. Okay, so how does it work? I mean, what's it do? Well, I mean, the thing is you get to control it. You get to decide whether or not it's on. So you don't have to use this. I mean, it's a fantastic tool. You'd be crazy not to use it, but you don't have to use it. So you can turn it off and go about your merry way, and everything's great. But you can also turn it on and take advantage of it. That's cool. Now, other things you get to control is you get to control the max plan size. Maybe you've got a plan that's just enormous, and it's going to take up a lot of resources. You know about it. You don't need to see it all the time. Fine. Let's make our max plan length a little smaller, and so now we don't have to deal with those. We're not capturing them. Same thing with queries. Maybe there's this monster query that runs at 3 a.m. every day, and you don't need to look at it. You know about it. You're going to be able to mess with it when needed and tune it as needed. But we don't want to have to capture it and put it into our systems and worse yet, deal with the fact that it's in there. Fine. We can set the text length as well on the query. Cool. We also get to set the data retention. Now, by default, it's 7 days, but we can set that higher or lower and capture more or less information and keep it around for doing those kinds of comparisons. Because again, what did it look like last week versus this week? Great point of comparison. So you've got that ability. We also can determine whether or not we want to capture plans at all. You could turn off explain plans. If you're saying like, oh, we feel like it might be putting a little bit more of a load in the system. We don't need the explain plans all the time. We'll turn them on occasionally when we need them, or maybe even we'll just capture one as needed. But what we still want to capture query metrics. Fine. Turn off the plans and keep going. And finally, you get to control the capture mode. Now you can turn capture mode to all, which is the default, and that means it's going to capture every query. and aggregate them up and feed them back to you for you to consume. Cool, that's great. Or you can capture top queries, queries that are taking longer, using more resources, and being executed more often. And so then you reduce the amount of information you have and get more signal and less noise. Or you can even turn off data collection from Query Store. Keep Query Store in place, keep it on your system, but not capture any queries. Maybe you're doing system maintenance, or maybe you're just trying to take advantage of some of the additional functionality inside of Query Store, which we'll get to a little later. And you don't want to, have to deal with the actual capturing of query metrics, but you still want to get that extra functionality. You could still do that because you can leave Query Store enabled, but stop the data collection. So there's a lot of control that you have over how this thing works. But you know what? The best thing to do, oh, yeah, sorry. Where are we accessing the data from? Forgot about that. There's going to be a database on your servers in Azure called Azure Sys, the Azure Sys database. On that database, there is a schema. Schema is, hey, Query Store. Hard to understand, hard to read. No, it's really straightforward. And then inside there are a bunch of tables and views, which we're going to hit in the demo and walk through it. So you know what? Let's get started on the demo. All right. Now this is the Azure portal. And on the Azure portal, I'm on the system server parameters for my Hamshack PostgreSQL database. And here, I'm going to just zoom in a little bit so you can see it. We've got, first up is the Query Store interval. Now, what's that? Well, the way it captures information is it captures it up into memory, and then after 15 minutes, it takes all the memory stuff and writes it out to disk and into those 1 hour segments that you have to look at in Query Store, which we're going to dig into. Don't you worry. We're going to run a few queries. Obviously, you can enable, disable Query Store. You can set the max plan sizes we already talked about. This is where you can control the capture mode, top, all, none. Now, would I recommend switching it to top? No, I would not. I would recommend leaving all the defaults in place initially, unless you know this already really well and you're going to configure it because the way you need to configure it for your system. If you don't know it, you're exploring, you're testing, you're validating that's going to work for you, leave the defaults in place, make adjustments later. Best way to start off, set off with the defaults and then make adjustments. But you can make the adjustments on you can make the adjustments on the number of days you capture, whether or not you're capturing plans, and then obviously whether or not you're capturing utility queries. Again, I left them all on because this is a demo system, but you probably would want to turn off utility queries on your own system. Do you have to? No, of course not, but it might be a good idea to turn those off just to kind of reduce the overhead. But that's it. I mean, that's how you run this, and it's pretty simple. Now let's go take a look at what it's capturing and how it's capturing it, because that's where things get fun. All right, so here in dbeaver, I've got some queries that we're going to run through, and I've also got the Query Store window open up. Let's take a look here. So as I said, Azure Sys database and the Query Store schema. Now it's got a number of Query Store tables and views already set up for you. Now the tables are a little hard to use. Personally, I like using the views better as I'm working through it, but you can go directly to the tables to get everything you need. So what you get is obviously plans and text. That's, come on, query text. What do you think might be in there? And then you've got stats definition, the definitions of the stats they're capturing, and then the stats entries. Then you've got the intervals, the values, and some other stuff. But you go down and look at the views, and you've got a Query Store view, Query Plans view, Query Text view, and you can use the views. Again, they're views. You can use them like tables and pull information together. So we take a look at it. We've got some columns in here, and sure enough, we can see all of the stuff going on. Blocks, max time, total time. So you can see what's happening. But let's look at real data. Let's go ahead and run queries. So if we take a look at just the Query Store texts, and we get, the queries that have been running on the system. And I'll zoom in down here so you can see it. But it's, select star from Query Store view where, I was running this query. So you can see there's a number of different queries coming in. And you know, it lets us know what type of query it is. So if there's some of the system queries or user queries or any other types of queries, you can see those and see what's going on inside your system. So there's the queries. I mean, it's straight up capturing queries. That's cool. Well, now what about stats query counts? Well, this is where things get fun. There is our start time and end time. And yeah, it doesn't start on the top of the hour and then bottom of the hour. It has to do with when your system either failed over last or when you actually launch the system yourself. And so that's when it starts and stops. So these times are not going to be, you know, 1:00:00:00 time to 2:00:00:00 time. Don't worry about it. But you can see the queries that have been going by. You can see the start and end times for those queries. And that's how we start to break things down so we can see, you know, again, before and after. So let's see if we take a look at a view. So what I do is I'm going to go to the query stat QS view, and I'm going to start filtering because just running everything all the time, again, doesn't get us information. So let's go in here and we're going to get SQL text, start and end time, the number of calls, the total time, and the number of rows affected. We're going to look at a particular database, and we're going to look at a particular user ID, and we're going to look at a particular date. Yeah. Oh, wait, no, that's far enough back in time. That would be a problem. Let's go ahead and look at a newer date. Cool. So the query is going to run. It does take a second or two. It's pulling all the information together. I would normally start talking about that local sports team, whoever your local sports team might be. Give it a second. It's usually about 30 seconds. And sometimes slightly longer. Come on, there it goes. 31. Okay, so you can see here's the query, and I'm running a very specific query. It's nothing special. I'm pulling together some radio information through a function. But you can see my start and end time, so my 1 hour. In that start and end time, that query was called, can you see it? 500,000 times. We can see the total duration that's running, and we can see, again, the number of rows that were pulled back. So we've got a lot of options going on here. And you can see that there's a whole bunch of other data you could pull together, but this gives you just an overview of what's going on. Well, okay, so what about wait statistics? Well, let's go ahead. Let's pull in the event type. We'll pull them in for the same database, and we'll see what's going on inside there. And so now we can see, you know, there's spin delay, proc array, client read, a lot of hits on client read right there. So a number of calls on client read. So now we can see the wait statistics are in there, and we've got an idea what's going on. And again, for a particular database, for a particular user. Can we look at it for a particular query? Yes, we can. We can make that combination too. All right, so let's just put it all together. I'm going to create a function. Function is returning a table with some information. Cool. It's basically the core query is going to get the start time, the end time, the number of calls, user ID, database ID. You get the idea. Total time, mean time, standard deviation on the time. Yes, they record the standard deviation. So if you just have the mean, it doesn't tell you enough. Now you've got the ability to do the standard deviation as well. I'm going to join those two tables together. And basically, I'm going to use the compare time to pull them together, and I'm going to look for anything where the max time has gone up on a given query. All right, so that's the function, and so we're just going to pull up that function for a given date. Let's go ahead and use this one. Now again, this query, once more, it'll take about 35 seconds. My network has definitely been acting a little funny, but that's how long this query has been running over and over as I've been testing it and getting ready to join you for this great event. But so it's gonna take another 10 seconds here, and then it will finish. So like I said, how about that local sports team? Because we do love the sports ball in IT. I'm kind of kidding. I'm kind of not. All right, here we go. Coming up on 40 seconds, and it's going to finish right there. Oh, come on, you silly thing. Of course, it's running slower now. There it goes. All right, so now what we've got, these are all queries that ran faster earlier. These are all queries that ran faster earlier. So now just running this query and this query alone, I got a starting point to start to proactively tune my queries. I am no longer guessing. I've got multiple points of comparison. I can bring in explain plans. I can bring in weight statistics. And so I am sure that I can start to really, really tune and identify my queries. And that's the goal here. All right, I'm going to go back to the slides here for a second, because there's a little more for you to learn. And that is the weaponization of Query Store. So Microsoft has a couple of things that they've done with Query Store that can help you. And the first one is Query Performance Insights. Now I'm not going to get into them in detail today, but I just want to bring them up so you know that they're there. Now, what's Query Performance Insights? Well, they're taking all of your Query Store data, and then they're running it through an analysis engine, and they're bringing up, hey, we think these are your problem queries. We think here are some possible suggestions, and here's some things that you could do, maybe get some better performance. Not necessarily carved in stone, not necessarily perfect. You may need to do some testing and validation, but Query Performance Insights will let you see what's happening with all the queries that you've captured in Query Store. Now, I like to dig into the data myself, but I would take advantage of this as a way, especially if you're managing one database, cool. You're managing 1,000 databases, you might want to have somebody else doing some of the analysis to help you out. And so they've done that. Now, the other thing that they've got is this intelligent tuning thing. Now, the intelligent tuning is, again, using Query Store, keeping an eye on plans and statistics and runtimes and all the rest, and using the fact that it has standard deviation and using the fact that it can compare before and after. With all of that, it starts to make suggestions on auto vacuum and some of the other things that you can do to make your queries run faster in an automated way. So you're not actually even having to go in and mess with stuff, add indexes, make changes. So that's really exciting as well. And with that, I am done. If there are questions, I'll be available in the chat. And thank you so much for attending. Really appreciate it. Get out there, use Query Store to tune your queries.
Well, that was great. I really enjoyed hearing about that. I know I've used pgstat statements in some other tools, but the thing that I like about this is it has so many, that Query Store is that it has so much information. And I love to think about developers, going in and actually examining which of their queries are, not performing the way they expect, and really taking the time to optimize them. That makes me feel good about spending time trying to make Postgres faster, because I know people are actually getting those benefits because they're optimizing their queries. So,
will they investigate when they find it goes faster?
And then they'll get to the point where they can thank me and send me a personal note.
That's right. Well, thank you again, Grant. Now, next, I'd like to remind everyone that we have the Cloud Skills Challenge on Microsoft Learn. There are 2 challenges, and if you complete them by June 24th, either one or both, you are in a lottery to receive a hoodie or a t-shirt. And I'd like to remind everyone that our speakers are on Discord in the #PosetteConf channel, and they're taking questions live. Speakers from the whole live stream. There's a lot of participation, so join us if you haven't already. And now we'd like to show you a trailer from our live stream number 1, yesterday's live stream, to show you, if you haven't seen the live stream, you can go back and watch it, but here's the trailer.
Hi everybody, my name is Charles Ferguson. I'm the Director of Product Management for Postgres at Microsoft. In my talk, in 25 minutes or less, I'm going to try and cover a variety of things that Microsoft is doing in Postgres, both our commitments to the open source aspects of Postgres and also what we're doing in the cloud.
Today, I will be talking about Postgres parameters. The title of my talk is Tuning Postgres Parameters versus Tuning Log Queries.
And I'm going to talk to you about connection poolers and their support for prepared statements. One of those connection poolers being pgbouncer.
Hi, I'm Paul, the CEO and co-founder of Supabase. Today I'm going to cover everything that you need to know about Postgres row-level security. I'll cover how to use Postgres row-level security, why you might want to use it, and some neat performance tricks.
And I'm going to talk about open source Postgres and how code gets into the Postgres codebase. And if you wanted to put a patch in, the process of submitting patches.
I'm currently leading engineering team here at Ikigai, and I want to share our story because it will give you a lot of insights if you're trying to build and develop an end-to-end AI platform using complex data types and complex AI workload.
And my talk today is called SaaS on Rails on Postgres. It's all about building multi-tenant SaaS applications and the capabilities that we have to scale up and scale out with things like Active Record, horizontal sharding, and Citus.
This session would be really helpful for the customers who are planning to migrate their on-premises workloads, especially Postgres workloads, into Azure, as well as our single server customers who are planning to migrate from single server to flexible server.
Welcome to Scaling the Wall of Text, Best Practices for Logging in PostgreSQL. This talk is for people who are new to Postgres, but also for those who want to improve their experience administering Postgres databases.
This talk is about how you could make your inserts faster, and any PostgreSQL developer who is dealing with data uploads, this is the best talk for them to go through.
Good day, everyone. I'm David Wheeler, creator of PGXN and principal architect at Tembo. Today, I'd like to talk about the state of the Postgres extension ecosystem, its past, its present, and the future.
It looks great. I'll have to go back and take a look because I didn't get to see most of live stream.
I was going to say the same thing. Yeah. That's what I'm going to be doing this weekend.
Cool. So up next, we have Taylor Troesh, and I'm really excited. So he's going to talk about how to get asynchronous behavior using DB queues. And this is a topic I'm interested in because it is really pretty disconnected from my experience as a hacker. I don't hear a lot about from application developers as much as I would like to about their use cases and how they're really using Postgres. And so Taylor is a prolific blogger and web developer. He's an Elm developer, which amongst other programming languages, which is really cool. I didn't know much about Elm until I saw that on his profile. I don't know if you
talked
do.
about it. I'll have to look up some talks.
And so he's also a doodler. If you go to his website, taylor.town, I got lost for 30 minutes just reading different posts because it's kind of, just go there. You'll understand what I mean when you see it. But it's very interesting. And he's so prolific. It's really awesome. But yeah, I'm excited to hear his perspective because of being an application developer, someone focused on front end, but also obviously needing the features that the database gives you and server-side logic. So I'm excited.
Now I understand why he calls himself the mayor of Taylortown.
Yeah.
All right, let's roll it.
Hello, my name is Taylor. I'm here to talk to you about Postgres, specifically task queues in Postgres, specifically how to implement and use them for great benefit so that you do not have to use something like PubSub or Airflow or Kafka, whatever those other things are. You could just use Postgres. It's very nice. So yeah, let's get into it. All right. But before I begin, I actually, sorry, I got to take care of something real quick. Yeah, cookies. No, thank you. No, thanks. Got it. Okay. Just got to do this real quick. Yeah, that looks good. Okay, purchase. Oh no, this is very not good. But as a developer, I can I can peek under the hood. Maybe this is something I can fix. MailChimp not found. MailChimp is a newsletter, right? It sends email thing. So I'm unsure why this is preventing me from doing my checkout that I desperately need. But I can imagine how it might work behind the scenes, right? It's you have some submit checkout function in their system, and they sign me up for their newsletter and then calculate the total and then send me a charge my credit card. But that little await statement means that it's going to throw and mess up the whole process if they keep it in there like that. So maybe they should have done something like this, where they don't await it, they catch it in case something goes wrong, and let the rest of the code proceed if something goes wrong with the email. But as a developer, you don't want to make the marketing team angry because you're skipping a lot of newsletter signups, right? They will not be happy. So what do you do in this class of problem? How do you take care of problems like this? Hello, I'm Taylor, and I'm here to tell you how to resolve problems like this. It's very simple. Just a little task table. You need some ID for your tasks. You need a task type. So let's say send email or something. And you need parameters to do the task. What this ends up looking like in practice is you have something like send email, sync data, right? Ingestion pipelines. Super good for anything that smells like ingestion, these task tables. Because what the task table allows you to do is do things later, but have a pretty good guarantee that it's going to happen later. And that later can be days, right? That very, very nice for things like that. So let's poke around into some of the implementation. This is the query that's doing pretty much all the heavy lifting. I'm going to talk about some ways that it's implemented kind of in the wild, but this is really the meat of it. You pick a task, you delete it, and you return it, but whatever system that you're using should wait to commit, right? Don't commit that query and delete the row until you've done the thing that you want to do. So in this instance, maybe send an email, right? You send an email and then you commit. Because as long as you do that, the row will not be deleted from the task table in actuality until you do that commit. So it's very important. So let's go into some of the technical details for how this works. This is the inner query, and this is the meat of it. If you take one thing away from this talk, it is that this is a very, very cool thing you can do in Postgres. These 4 lines. The first line locks a row. It tells Postgres, hey, I'm going to be doing something with this. No other queries better be doing something with this, right? I'm gonna just hold on for a second. That's what you're telling Postgres. But you might be one of those other queries that is trying to get into somebody else's row. What the default behavior in Postgres is if you get to one of those 4 update locked rows, it will wait. You will wait until that whole transaction is done before you can even start. So skip locked your query only relates to unlocked rows, right? So things that you can pull from immediately. We only want 1 row. I have made the mistake of trying to pull multiple rows at the same time, but the problem is if you're doing multiple async things, which you probably are, then they can fail independently, and that means all of the deletions that you have in that outer query are predicated on everything succeeding or everything failing, which is not a case you want to be in. So only take 1 row. And last but not least, order by random. This task queue, your task table, if you pull in a predictable order, then what you might, if you write some worker code that is not good, if you're me, then all of your code is not good. But let's say there's a particular bug in your worker code. You don't want it to get in a loop and just keep on trying and failing. You want it to randomize so that if there's a problem, it can just try something else, and maybe it'll get back to that later. But you've removed the problem of these terrible retry loops. Yeah, so you're probably thinking like, hey, this query is really cool, but there are tools that do this kind of thing for you. Why would you implement it in Postgres? And I'm going to try to make a case for exactly that. So this is some message queue-like system, right? You take the next message out of the message queue MQ, and you acknowledge the message. And once you acknowledge it, then you're telling the queue, okay, you can remove this. This is just a common way that message queues are implemented. In this case, we want to send an email, and then we're going to go mark that email as sent in our database, and then we're going to tell the message queue that it's done. Now, there is a very bad bug in this code, very bad, namely that you see mailgun.send happens before we actually tell Postgres and we mark it, which means that some unfortunate folk, some unfortunate person might get a ton of emails because, let's say, there's a typo in the SQL query, then it's just going to keep on sending that message because it will never be able to remove the message from the message queue. So this is maybe what an implementation would look like that doesn't have that error in it, where it's a little bit safer because Postgres can prepare that message or prepare that query and then commit it after the email's been sent. But this is you might be getting that weird feeling that I am, that there's complexity here that doesn't need to be, and that you're using a thing to use a thing, and maybe you can just do it simpler. And this is my whole thing is I like option 2. I like doing things one way. A message queue, you can very easily implement it in Postgres, and the performance is pretty good. So at least for simple things, which is most of my code, I try to keep my code dumb and simple. It works out very well. All of these things are things that I prefer not to use because I like using Postgres. Postgres happens to just work extremely well for these small cases. And my examples, of course, are like a little bit, they're small, so you can see the conflict. You can see that it opens the transaction. Normally, code bases are a lot more spread out, so it's harder to see that these things are going on. But in practice, what you're doing when you use two systems like that, you have some database and you have some message queue or ingestion pipeline, something like that. If they both have their own state, what you end up having to do is implement two-phase commit. Now, I'm not going to explain to you what two-phase commit is, but it sounds complicated because it is. All the smart distributed systems people, they have figured this stuff out. And when you try to use two databases or message queues or anything like that, you end up having to pretty much implement this really hard stuff. So I've talked a lot about theory and even given you some scripture. So let's go into practice. What does it look like, really, to implement the worker, implement this in a system? What parameters can you tweak? So this is an example of a sign up endpoint, right? You post to sign up and it creates a user and then you send the email. If you remember anything from the past few minutes, this can be simplified a little bit, and you can reduce a certain type of error. See that if you create a user and then send an email, but the email doesn't send, and then you set a cookie, right? There are things that can go wrong here, but the email is not that important. It doesn't need to be sent right now. You need to create the user and set the cookie. That's what needs to be set right now. So what I would do is, just in a CTE, insert into the task table. Don't worry about sending the thing right now. Some other service will pick it up and send the email later, and that is a little bit more code, but it ends up making the paradigm a lot simpler in my opinion. So this is how I roughly implement my workers. You have a while loop, single worker, it's just a while loop, takes tasks from the task table and runs the task, passes the parameters in with a transaction. I'll get to that in a second. But it's very simple. The nice thing that happens when you implement it like this is you can put tasks in there that are not actually implemented yet. And what you end up getting is like, okay, you write the code, you put a send email welcome into your task table, and your workers are now just going, oh, hey, I don't know what to do with that. And it's very nice waking up and saying, what should I do today? What should I do in my code base? Oh, hey, this is a to-do driven development. I know exactly what to do. And things, in some sense, break exactly where you want them to break. This may seem weird for maybe sending an email is not a great example of this, but again, ingestion pipelines. I've worked on a lot of ingestion pipelines, and it is so nice to be able to spawn a bunch of things, and then it's like, okay, I just need to implement this video or audio thing, blah, 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 blah. And I can do that in my own time and not have to do the whole pipeline at once. So this is what it ends up looking like when I implement a particular task. I just have it in a dictionary or object, right? And the key is the task name. And what you do is you pass the transaction. You pass the transaction with the parameters into your tasks. And what's very nice about this is if you, oh boy, sorry for the wrapping. What is very nice about passing that transaction into your code, if you want to do another query, right, with the information that has been provided in your params, let's say you want to update the status of some related thing, it also could be done in the transaction, and all of it is predicated on that await thing that you want to do, that asynchronous work. So for the sending an email, right? You can go and do whatever work you want, kind of queue it up in the database. It won't happen until you do that send email and then commit, right? You just batch it all together. And that's something that is very nice to have in your task worker. So this is more implementation stuff, right? Not super important. I have a bunch of code on tailor.town/pg-task. And you can copy paste all that. Code's not super important here. This is what one of the tasks might look like. Here's an example of updating the email count, right? In that same transaction. I'm using Porsager's wonderful Postgres library in TypeScript, and very highly recommend it. It's a delight to use. One nice thing about this query is that you can run them in parallel because the for update skip locked. You can run these workers kind of at the same time, and they won't collide and step on each other's toes. Order by random, not a great thing for very big tables. If you have more than, like, I don't know, a few 100,000 rows, you might consider using table sample. Another weird thing you can do is you can order by task type. If you stick that first, what will happen is you get a prioritized queue for free. Amazing, right? You can maybe send urgent emails first, or do certain parts of the ingestion pipeline first. Within that task, you do random. You use a case statement to group these things together. Very nice little pattern. Another pattern that ends up making the code a little bit more complicated, but is totally worth it, is incrementing the attempts before you increment the attempts before you kind of start the whole task dance. And what that gets you is a free way of tracking attempts, right? Which is very nice when you're sending emails or things that you really don't want to do a whole bunch of times in a row. So little pro tip there. More pro tips. I used big serial earlier. Do not use serial in Postgres. You're not supposed to. Use the identity thing. You can use enums. I find that it tends to be slower for development. You have that to-do driven development, so you don't really need the enum, but could save space, right? Makes your column a little narrower. HStore you can use instead of JSONB. You can add a uniqueness constraint, and that'll give you a little bit of idempotency. If you add tasks quickly in succession, it won't mess things up. The human aspect of this, I give you a whole bunch of tech stuff, but the real human thing is that let the computers do the retry loops. If I'm in my checkout process, right, I don't want to have to keep on pressing checkout, purchase, or maybe go take a nap, come back later. I'm like 160, 170 pounds of attention deficit meat, and I've got lots of stuff to do, and I don't want to do retry tasks that computers are perfectly capable of doing. I just want to make my purchase. Thank you. That's it for me.
That was great. I love Taylor's style. And first, the narrative style, and he did a little bit of acting to take us through, and then this I don't know if I want to call it self-sufficiency. I mean, the attitude of the Postgres community of like, Postgres can do this. Why do we need to add another system? And we see that pattern across so many problem solution areas, and it turns out to be right. It can be done.
Yep, very cool. So just a reminder to fill out the survey to give feedback to the speakers at k.ms/Posette survey talks and Posette survey event to give feedback on the event itself. And another reminder about swag. I think the code will flash up in now. Okay. Yep. So get your sticker packs. And now we have the Livestream 2 trailer. This happened in Mia time zone last night. And just to get an idea, you can go back and see Livestream 2, and let's watch the trailer together now.
Hello, I'm Regina Obey, and today I'm going to talk about the open source geospatial community, Postgres, Postgres, and how Postgres joins the two.
Hello, I'm Heikki Lindenäs. I've been working on Postgres and traditional databases for a long time. Today I'm going to talk about the vector data and how vector data is different from other kinds of data.
This talk might be interesting to you if you happen to work with PostgreSQL, if you want to learn how to employ recent developments in machine learning models into your PostgreSQL applications.
I was a former intern in Citus in 2022, and a part of this talk will actually address a part of the work that I did as an intern in Citus. Mind you, I was completely new into databases. I never heard about PostgreSQL, and I barely knew anything about any software engineering practices. So if you are also a beginner, please stay tuned for this talk because it might be interesting for you.
Hello everyone, I'm Marcos Lott. I'm a software engineer at Crunchy Data, and I'm going to be talking about data-intensive Postgres 3 ways to scale, or rather 3 different types of workloads that you might struggle with on Postgres if you have a data-intensive application.
Hello, my name is Silvano Coriani. I work in the Azure Postgres team, and I'm here to present about high availability and disaster recovery for Azure Database for Postgres.
So I'm Chris Ellis. I'm kind of head of technology here at Next Team, and at Posette 2024, I'm going to be talking about JSON-B with Postgres still needs some form of schemas, right? And this is a talk very much about dealing with those kind of situations where you don't really know what data you're storing all the time, or you're just dealing with kind of quite complex data structures that you don't really want to just map into tables.
And the story that we are going to see is not the typical presentation with the slides and bullet points. This one is a storytelling, so it's a different format. And we were going to go together with Monica De Bea, a tremendously talented support engineer who is going to investigate together with Kevin and Dirk about a problem that Dirk has with his project with synchronous replication. So we are going to go step by step until we find a solution to Dirk's problem.
And we're going to be discussing neurodiversity and how it affects interactions within the workplace and the IT community in general.
And I had just given an internal talk about my ADHD diagnosis and how I've been basically coping with something that I, had all of my life, but I only found out about fairly late in life, right? And asked if we could talk about it together. And we talked some more and figured we should submit something to Posette.
Today my talk is about how we can accelerate migration to Postgres on PGSQL when we are migrating away from commercial engine like Oracle or SQL Server.
Hi, my name is Ryan Booz, and I'm excited to be talking about PostgreSQL partitioning at Posette this year. Now, as our databases continue to explode with more and more data every day, partitioning is key to really understanding how to manage both performance and maintenance of your database. And I can't wait to talk to you about it.
So many great talks. Extra stuff to watch this weekend. I couldn't watch. I can no longer stay up all night. So
I definitely can't. I was just saying the other day, I've completely ruled out red eyes because it's just like I need my sleep.
Yeah. So the next up next we have Denzil Ribeiro, and I am really pleased to introduce Denzil because we've worked closely together. Denzil is a principal PM manager in the Azure PostgreSQL team. Most of his career, he's been at Microsoft building databases and data solutions. Before Postgres, Denzil worked in Microsoft SQL Server. In the product team, had roles in the customer advisory team for SQL and Azure, and worked directly with strategic customers as a field engineer. Denzil's talk today is about developing with Azure AI and PostgreSQL. Here we go.
My name is Denzil Ribeiro. I'm a principal product manager at Microsoft working on the Postgres service. And today I'm going to talk about 6 things you can do with the Azure AI and Azure Local AI extensions, which are first-party extensions. They greatly simplify building Gen AI applications on Postgres. So the first thing we'll look at is vectors and the importance of vectors in the AI era. Raw data such as video, text, and audio are passed to a deep learning model, which creates something called embeddings. And embeddings is nothing but an array of real numbers that represent the text or audio or video in a format that machine learning algorithms understand. And then using these vectors, then you can calculate distance. Distance between 2 vectors being close means they're similar to each other. And this vector similarity forms the basis of, semantic understanding tasks such as recommendation systems, query answering, and LLM retrieval. and they form the basis of also RAG, or retrieval augmented generation. So RAG patterns with Azure Database for Postgres work like this. You have unstructured data, which is your text or audio or video, which is chunked and passed to an embedding model. And that embedding model, as we talked about in the prior slide, creates vectors, which can then be stored in Postgres or Azure Database for Postgres. And then when a user asks a question, if the question doesn't have context and you go directly to an LLM, the LLM or the large language model has only public data, or is trained on public data. So it'll produce an answer such as, which is generic in nature. So if the question is, does my vision insurance cover LASIK? The answer would be more generic because it doesn't have information about domain-specific data, with regards to your insurance. However, if the question is augmented with context, aka you ground the LLM based on context of the data. So the question creates an embedding. The embedding is then searched within the database to get similarity results. In this case, it pulls out data to do with your insurance policy around your question and gives the most similar results to the prompts. And those prompts are passed to the language model. Then you'll get specific, answers. And, the question to the LLM is grounded on your data, and it then can figure out that, for example, your insurance covers LASIK with some stipulations. So Azure Database for PostgreSQL has native vector search via the pgvector extension. So you can enable the vector extension, and it allows you to durably store and index vectors and metadata at scale. So there are indexing strategies. We're not going to go into the details of that. You can index with IVF flat or HNSW and combine the vector queries. So this is not a specialized vector database. So your vector data resides along with your operational data. You can combine vector queries along with metadata search and then also enable ACLs on the vector data itself. So it's as simple as creating the vector extension and then inserting embeddings into a vector data type, which is a part of the table. So the Azure AI extension is a way for you to integrate, Postgres on Azure along with the AI ecosystem. So via SQL, so all the interfaces are SQL interfaces, which are user-defined functions, and they communicate with Azure OpenAI for embeddings, with Azure AI Language Service, which provides a host of language services such as sentiment analysis, summarization, key phrase extraction. You can do real-time translation via the AI translator, and then also invoke either custom-trained or pre-built models via Azure Machine Learning. And this is now generally available. We just announced GA a couple of weeks ago. So coming back to the 6 things we would do with the extensions, the first one is creating embeddings. And it simplifies creation of embeddings really a lot. The application, makes a call with a query to do a semantic search, for example. It's asking for high protein recipes. The database itself then talks to Azure OpenAI, passes the search string, which is high protein recipes, invokes the REST API call for Azure OpenAI, and then Azure OpenAI text embedding model returns a vector, which is the array of float data, and then performs the similarity search, which was the inner product, comparing, similar to high protein recipes that exist on the database, and returns the result set. So without this, the application would actually have to talk to OpenAI itself, get the embedding, then pass the embedding in the SQL to the database and get the result set. So this simplifies that operation greatly. Remote embedding considerations. We support all the Azure AI embedding models, the text ADA 002 and 003. In text ADA 003, you have granularity, or you can specify the number of dimensions from 384 till around 3000 dimensions. And dimensions have a play in accuracy and recall. Just remember that Azure AI deployments have a token for tokens that you configure for deployment, and that controls the rate of requests it can receive. So you can specify as part of the call, timeout, retries, and delays in case you get rate limited based on the configuration of the deployment of Azure OpenAI. If you're not happy with the embedding models that exist on Azure AI, you can host custom, embedding models on the Azure ML integration piece that we'll look at a little later. And then this supports scalar or patch embedding generation. The second scenario we'll look at, which we've just announced in preview, is generating in-database embeddings without even having to go to Azure OpenAI. This is now in preview. So in this scenario, the application talks to the database, and the database hosts actually an Onyx runtime. The first model we have hosted is a multilingual E5 small model. This is an MS research model that is on Hugging Face. So, after the call for creation of embedding comes to the database doesn't even leave that machine, generates the embedding, and then returns that embedding to the application. So as I indicated, the multilingual E5 small is the model that is actually used as of now, and you don't have control of getting a custom model at this point. So why would you use in-database embeddings? The first reason is to reduce latency during embedding creation. Talking to an external service means there is a penalty for a round-trip latency of generating the embedding. The second is leveraging embedding models at a predictable cost, so you don't bank on multiple services. The billing is included in the billing for the database. And the third is to keep database data within the database boundary itself. So if you have any requirements where you can't leave the database boundary, this is a way to use local embeddings. The simplified search experience is the same semantic search query looking for high protein recipes is passed to the database. It doesn't leave the database. That search string high protein recipes goes to the Onyx runtime, returns the vector. Similarity search is done within the database, and the results are returned to the application. So let's look at the demo of embeddings and the couple ways of doing embeddings. The first is with the Azure AI extension. I'm here in my Azure AI studio, and I am looking at deployments where I've deployed a text embedding 3 small model. The model name you can see there is the text embedding 3 small. And while configuring, I've configured a rate limit, which also limits kind of the requests per minute, right? So when you configure the deployment, that's what you configure. Now you have to allow list extensions in Azure before you can create extensions, and that shows you the extensions that are allow listed. This can be done from portal or API or CLI. The 2 extensions we are going to look at besides vector are the Azure AI and Azure Local AI. Azure Local AI is the new kid on the block that we've just previewed. We have a listings table. We are looking at Airbnb or vacation rental type scenario. So you have a listings table, which is a normal. And if I do a natural language like query, like looking at homes near Pacific Science Center that allow pets, with a traditional search mechanism like a like clause, returns no results. Similarly, full text search also isn't good for semantic search or similarity search. In this case, I added a TS vector query and did a text search. Still, I get no results. So let's look at creation of embedding. Before I generate embeddings, I'm showing the simplest form of creation of embedding. You call the Azure OpenAI create embedding UDF, and point it to a deployment in OpenAI, and then you pass it the search string, of course, the input, which is vector and embeddings power gen AI application. And there are parameters to ask for dimensions, which is text ADA003, and attempts and retry delay. So you can add now pretty easily embeddings to a table. For example, adding a column of vector type 384. In this case, I'm using 384 just because I'm going to compare with local embeddings. This is generated as always, so every insert actually generates the embedding. And then I pass the other parameters we've seen before. So if I look at the top 5 listings, I see the description vectors generated for all my listings. And now to search, to enhance my search speed, I create indexes, HNSW indexes in both cases. And the type of index creation depends on the similarity search you're going to do. In this case, cosine similarity and inner product. Now I can do my nearest neighbor or similarity search. And I've asked for 5 listings in this case with free parking and pets. You see free parking in this case in the title. And then if I flip to pulling the description, it's pulled out that it had a dog walking trail and dogs can come in. So it's deciphered that pets are welcome in the text. The syntax is the order description vector has a cosine similarity search. Now, near Pacific Science Center might not actually mean much in terms of distance. It's relative. So I'm going to get the coordinates here for the Science Center. It's Seattle. And then use these coordinates to actually enhance my search. So in this query, I am doing 2 parts here. I'm going to search for vacation rentals within 2 miles of the Pacific Science Center because I have the coordinates, and add some additional metadata predicates. And then along with that, I'm going to do my similarity search, just like before, where I compare cosine similarity, the description vector, to my search string. And as a result, I get, a few hits, 4 or 5, places. I'm limiting to 5, within 2 miles of the location in interest. If I look at any one of them, you'll see that not only did it, get it within 2 miles, it also, deciphered that pets are welcome and parking is included in the most similar properties within my search parameters. So that is, we've looked at remote embeddings at this point and similarity search. The next thing we're going to look at is the same scenario with local embeddings. So I've made a copy of the table with listings local AI, and I've added already and pre-populated a description vector column, just like before. The only difference is these embeddings would be locally generated. The simplest form of generating the embeddings is calling the Azure Local AI Create Embeddings, UDF. And this time you pass the model URI and the input. It spits out the embedding based on this multilingual E5 small model. So similarly, I've updated the embeddings in this listing table because they take a little bit of time to generate. And the same similarity query as before now works. Now the results might be a little different because the model is different and your embeddings are different. So recall and accuracy between models plays a role here, but it returns results that satisfy the criteria, per the model. And if we look at performance now, I'm going to generate embeddings, 100 embeddings just for good measure with the local UDF. So these are generated in database. And I do an explain analyze and see that these 100 embeddings took about 1.3 seconds. Which is, pretty good from an average perspective. If I look at remote calls for kind of the same scenario, 100 embeddings, calling the Azure OpenAI Create Embeddings call, you see the same 100 embeddings took, 6.2 seconds. So that shows you the difference in speed between local embeddings and, remote embeddings. So to show that further, I have just wrapped those embedding calls within UDF. So get remote embeddings gets it from an OpenAI deployment, and get local embeddings gets it from the database. And I'm running pgbench in both cases. you'll see a difference in TPS on the left and on the right. This is just one client. The TPS is around 242, and the average latency is 4 milliseconds, versus the TPS on the left at around average latency is 61 milliseconds, and the TPS of around 17 embedding generations per second. So that's embeddings in a nutshell. The next thing we're going to look at is some of the language services. We'll start with sentiment analysis. These are machine learning models using NLP techniques that detect the language. Language detection is at the forefront or key ingredient of any of these language services, and they provide sentiment labels. So they classify, for example, a review as negative, neutral, or positive, and provide a score for each of those. And they support like over 100 languages or around 100 languages. So the sentiment analysis can do sentiment analysis on about 100 languages. And that's done via the Azure AI extension. And I'm going to club a couple of these before we go into the next demo. The next one is summarization and phrase extraction. These are used to, if you've seen Amazon, you've seen the AI-generated summary of reviews, for example, or can be done to summarize legal documents. There are abstractive and extractive summarizations. One extracts points within the document. The other actually summarizes the document. And again, these have multi-language support. And the next fifth thing we'll look at is real-time text translation. In real-time text translation, again, we detect the language automatically. We are able to translate in 100 plus languages, and we are able to transliterate, which means it's more of conversion of characters into the different language rather than literal translation of sentences. And then there's other functionality such as filtering out profanities and the like. So let's look at a demo of Azure AI language services and translation at play. So here, the first underpinning of language services is language detection. So Azure Cognitive is the schema here, and detect language detects the language of any text, and it's implicit in most cases. You don't have to actually do a detect language. So I have a reviews table for my vacation rental, and detecting sentiment is as simple as calling a UDF, Azure Cognitive.analyze sentiment, and then out comes a sentiment text, positive, negative, and neutral, and a score for each of those components. So you can do things like take all your reviews and average them out. For my top listing, for example, which is listing ID listed there, I can actually do an average score. It seems like it's a pretty good listing with 34 positive reviews and 1 negative review. Or I can combine some of these functions. In this case, I'm combining a summarize abstractive along with all my reviews. So I take all my 34 reviews and pass it to summarize abstractive. I aggregate or do a string ag on all my reviews so that I combine that to form a document. But you could summarize a document as well. And I get a summarization of that review. So in this case, you'll see I copied this out. You see the reviews are generally positive. So the overall summary is positive. In addition, we have other functionalities such as key phrase extraction. If you want to highlight the key phrases within a document or a review or a listing, in this case, there are the key phrases that you could highlight. And last but not the least, I snuck in another one, which is PII redaction. PII redaction actually identifies what elements of a string have PII. So things like, a name, an address, an email address, a company name, and then they'll mask that out and give you the classification and the confidence of that classification that you can actually get for the redaction. So these are language services in a nutshell. Then we'll look at translation. Translation in real time also is very easy. We have the Translate API, And in its simplest form, you pass a string and a language, and you get the translation, right? You can also do this in multiple languages at a time by passing an array of languages. Here, you got the same string into multiple languages. And then there are things that you can do around, profanity filtering, for example, where you can either delete profanities or mark profanities or put a placeholder for profanities. So in some languages, and it is language sensitive. So idiot, for example, is not necessarily masked out in certain languages. So you can use the same thing to translate reviews, for example, in the locale of a user. If you have an international audience, for example, here's my listing in question, and I've translated all these into Portuguese. And then all these UDFs, for ease of use, could be wrapped in a function to simplify, calling into them even more. So in this case, I'm getting translated reviews in French, and the top 5, right? The last area we're going to look at is real-time predictions with Azure Machine Learning. So Azure Machine Learning has a robust platform and can expose real-time endpoints. And those endpoints you can use for real-time scoring or predictions. They have inbuilt features like you can define the cluster size, there's auto scale, you can enable traffic routing if you have multiple models, and you can host a variety of models. You can train your custom models that you want, or you can host pre-trained models from a catalog of models. If you're not happy, for example, with the embedding models that we talked about already, which are the ADA 002 or 003 or the inbuilt in database one, you can host a custom embedding model as well. So the last demo we'll look at is the Azure ML integration. Here I have Azure AI Studio. And in my Azure AI Studio, I have the online inference endpoints. Here I have an online inference endpoint that is hosting a few models here. The one we'll look at specifically is the California housing, but I also have a pre-trained model, which is the Phi2. The first thing you do is once you deploy the model, and we're not going to go through the training exercise, is to test the model within this interface as well. Because if it doesn't work here, it's not going to work within the UDF calling it. So here I've passed, 2 arrays of data, which are 2 sets of features, and I got 2 predictions. And to configure, you would configure the endpoint for this within the extension, which then uses it to call into that. So here I have a table which has my features that the model require. So this is a house prediction model. So as you can expect, the features include things like average rooms, age of house, population, and so on and so forth. And the output is the house value in hundreds of thousands. So in simplest form, you invoke with a JSON parameter, pass the input data that the model expects, and call the Azure ML.invoke, passing with the deployment name in question, and then pass the input data that the model expects. Here I'm passing 2 sets of features. Similarly, you can build that JSON input for a specific property. Here I'm building the array for the features and building the JSON object itself. And then once I have those 2, I invoke the Azure ML.invoke for that deployment in question. And then you will get the price prediction for that one listing, which has ID 18,000. And that's the price prediction. So the easiest way to do this, both to figure out the resources it takes and the number of times it's invoked, is to create a function, because you can then see usage of that function. Has the same logic, and we invoke it with the listing ID. Here it converts it into a real. If we validate a model, it was 2.7 million. It's 2.7. The actual was 2.773 million. Our model is pretty good. So I'm showing you a pre-trained model here, which is the Phi3 model. It's not something you would actually use within a database, but want to show that you can include pre-trained models here. So this is a text generation model. I ask it the question. It's an LLM. I ask it what's the most loved Postgres function or feature, and it replies with it's the support for advanced data types and functions which allow complex and efficient data manipulation. So this is an LLM grounded on public data set, of course. So we've seen several things now. We've seen the Azure AI extension, the Azure Local AI extension. We've seen embeddings, similarity searches. We've seen Azure ML integration and a host of language services. All these greatly simplify building Gen AI applications on Azure Database for Postgres. Here are some resources that have documentation and other links to learn more about the feature. I appreciate your time. Thank you for listening, and we are eager to hear about all the awesome things you built with the Azure AI extension.
Well, thank you, Denzil. And I was just impressed by the demos, and I just love all the AI capabilities that Azure Postgres is offering right there in the database. Again, with that theme of you want to use the database directly and give the database capabilities, and then we're starting on this journey where the models come to the database with Azure Local AI. We want to remind everyone that the speakers are on the chat. There was a lively chat happening throughout the live stream. In fact, there was quite a lot of jokes going on in the last in this past session, and it's the hashtag PosetteConf in Discord.
Really feels like a hallway track, right?
Yep.
So next, we're excited to hear from Newvick Lee, and he's going to be he's a software engineer who's worked in the healthcare and fintech spaces, and he's going to talk about how to use Postgres views to revitalize legacy data models. The thing that I'm very interested in with this is usually when I think of legacy software, legacy data models, you think of old software at a big enterprise company that's 10 or 15 years old, and it will be so difficult to change it. But he's actually coming from the perspective of thinking about when you're a startup and you're moving fast, how do you actually avoid having to refactor as often? And I think that's like a really interesting perspective. It kind of goes to show that, it's something that every type of company, at every size and every stage of development has to think about how to really use tricks and tips like what he's going to share to be able to get business done.
Fascinating. Okay, let's roll it.
Hi, my name is Newvick Lee. I'm a software developer. And today I'm going to give a talk on how to use Postgres views to revitalize your complicated or outdated data models. I think this is very relevant for software developers who are working in startup environments where your data model is constantly changing. I hope this is a technique that you can use to help you out. Now first, I'm going to start off with a question. You're using a complicated and or outdated data model. It's a very common situation. What do you do? A, you factor the data and all the related code. Now this is the ideal solution here, but most of the time, we actually don't have the time or the resources to do all this refactoring as much as we'd love to. So we'll have to cross that out. Unfortunately, B, it is the only alternative to just give up and continue using this complicated data models grudgingly. I'm going to argue that you can actually do something else. And that something else is the topic of our talk and the goal of today, which is to learn about Postgres views and actually how to use them to improve your data models. This is an outline of what we're going to talk about today. We're going to first review an example case and then move on to what is a Postgres view and how does it actually help you. And then we're going to try creating a view and learn that actually views are updatable. But if we want to improve our update process, we can use triggers and functions. And there's also some useful parameters that we can look at, And finally, we'll end off with a short contrast between standard views and materialized views. Now, our case study is a complicated data model, and it's going to have some polymorphic associations. Here's our table, farm, animal, barn. We're going to just focus on 4 columns, and these 4 columns are actually grouped into 2 polymorphic associations. We can see here that the first one is the animal type and the animal ID. So that's one polymorphic association, and the second one has to do with the barn type and the barn ID. And we'll see what this actually means. Here is some example data. Now, let's just take a look at this first row here. If our animal type is chicken and animal ID is 5, this animal ID actually refers to the chicken table ID column. And if the barn type is large barn, the barn ID actually refers to the ID column of the large barn table. And then the second and third row shows you a bit more about what this polymorphic association means. So in these second and third rows, our animal type is duck. But if we look at barn ID, they're both 8. How is that possible? Well, that's because in the second row, it's part of the small barn type. And in the third row, it's part of the large barn type. And because they're referring to 2 different tables, because they're 2 different barn types, that means that it's okay for them to have the same barn ID because they're in 2 different tables. Just to make this extra clear, just because I want you to understand this case example before we move on, this is how it looks like if we kind of graph out the relations. So first, let's take a look at the one on the left here. So you see how animal ID is pointing to either the chicken or the duck table. So it can be either one depending on the animal type. And that's actually the same for the right side here. So the barn ID can refer to either large barn or the small barn ID column, depending on the barn type. So that's what it means to be polymorphic. And in our example, we have these 2 polymorphic associations. Now, how would you query for this using SQL? You would select from the farm animal barn table. And then in the where clause, you have to make sure you have at least these 2 clauses down. You have the animal type, which is chicken, and then the barn type, which is large barn. So that's how you query for a chicken in a large barn. Now, how we do that for if you wanted to query for a duck in a small barn. Select from that table again, and then the only things that change are in the where you would go for animal type equals to duck and barn type to be small barn. Very similar, except you just have to change the where clauses for the animal type and barn type. So this is our case example. It's used to represent probably potentially more complicated data models that could actually exist in practice. And for example, like these are some of the ways that it can be more difficult to work with. You could have potentially more animals, more animal types, maybe a cow or horse. You can have many more barn types as well. A wooden barn, maybe a small one, extra large. And you can also have a lot more polymorphic associations in the same table. So I've seen all of these cases in practice, and that's why I chose to use this example case as something that could be very complicated. Now that we've learned what our example case is, we're going to move on into what is a Postgres view. So just briefly, a Postgres view is a virtual table. It does not store any data, so it's not physically materialized. And what it is, it's just a predefined SQL query that acts like a regular table. You can think of it as a shortcut for that predefined SQL query. And this is the syntax that's pulled from the Postgres documentation. You can see that in the first image there, you do a create, and then there's a bunch of options, view as, and then there's a bunch of options as well. I will slowly get into that. You don't have to worry about that yet. So let's take a look at the second image there. Create view vista as select, and then it's just hello world string as the hello column. So if you want to see just a very simple example of what it looks like to create a view, this is it. You have one column with one row, and that's the simplest case of a view. Now that we kind of understood what a view is, let's try using a view to help with our example case that we looked at earlier. Now, if you remember, this is what it looks like if you wanted to query for a chicken in a large barn. It's actually, it can get relatively complicated. You have at least 4 different where clauses here. And then you have animal type, animal ID. It can get a bit confusing. So we're going to improve this. And the first step we're going to do is to create a view for this. So let's take a look at the syntax here. We're going to create this view, and then the name of our view as. And everything after the as is our predefined SQL query. So we're going to select, and then I'm actually going to talk first about the where clause. We're going to select from the farm animal barn table. And then in the where clause, we have 2 specific ones. The animal type equals to chicken, and the barn type equals to large barn. And because in our view we'll always have chicken and large barn, that means that the animal ID, we can rename it as chicken ID to make it more clear. And same for the barn ID. We can rename it to large barn ID to make it clear that that is a table where the ID comes from. And after we've created that view, we can use it to query. So I have this contrast here to show you what that difference is. On the left side here, we have the original query. It's quite long and it can be a bit complicated. On the right side here, when we're using a view, we can see that it's actually a lot simpler, less lines of code, and also more clear. So we're doing a select, these 3 columns, from chicken and large barn. That's the name of the view. And we can see that it's not animal ID, it's actually chicken ID, because our view says that this view will only show chickens, and it shows a large barn ID because this view will only show the large barn. You can see that it's a lot simpler to work with, and it's also more intuitive as well, because the columns are named after the types in the view. Now, after we've queried for it, what does it actually look like? Let's take a look here. On the left side, that's what the original table looks like, the farm animal barn. And then on the right side, we can see that it's a lot more succinct. So let's take a look at the animal polymorphic association first. So you can see the animal type chicken and the animal ID 5. It kind of gets transformed into just chicken ID 5. And also the same for the barn polymorphic association. These 2 columns, barn type, barn ID, they get transformed into large barn ID. And you can see the view is a lot simpler. The outcome of this is that now querying is much simpler for these polymorphic associations. So we saw that you can query for chicken and large barn, but you can also create views for the other types. For example, you can create one that's specifically for maybe a duck in small barn or a duck in large barn. And all these views will make querying a lot simpler for the types of data that you want. Now, you might be wondering, what about other actions? We don't only query data, of course. We also do insert, update, and delete. How do these views treat these other actions? That's a really good question, and I think you'll be happy to hear that views are updatable as well. In fact, they are automatically updatable. They satisfy those conditions. Now, what does it mean for something to be automatically updatable? So in our example view, we had chicken in large barn. We could just do a select star from that table, and we can get the data we want. Now, if it's automatically updatable, it means that we can just do insert into that table, into that view, chicken large barn. We can do an update. We can do delete. That's what it means to be automatically updatable without doing any extra work. But it has to fulfill all these conditions. So it has to have exactly one entry in its from list. Also, it should not contain anything like with, distinct, group by, having, limit, or offset clauses. Also, it must not contain any set operators. So stuff like intersect and union, and the select list, finally, it should not contain any window functions, aggregate functions, or any set returning functions. So if your view fulfills all these conditions, you can update it without doing any extra work. And like I just mentioned, this insert into our view with chicken ID 2, large barn ID 3, that's actually possible without doing any extra work. But, and there is a but the animal type and the barn type will be null. So that is a bit of a problem because they definitely can't be null. If they are null, then how do we know what they actually refer to? So that's where trigger functions come in. If we want to improve the update onto our views, we can use a trigger to replace the insert on the view. Let's take a look at what this is doing. So first line and second line, we're doing a create replace function, and then we're naming our function. And then in the third line, we can see that we're returning a trigger. And if you haven't used triggers before, I'll show you later on why we're actually returning a trigger. But the meat of this function is actually in between the begin and the return. So in that insert statement there, we're going to insert into the base table, the physical table, farm animal barn. And let's take a look at the first column we're inserting into, animal type. We are hard coding that as a chicken string. And why are we doing that? Because remember, we're inserting into our view chicken and large barn. So it expects that everything we're inserting into is of the chicken animal type. And then what are we going to insert into animal ID? Well, we're just going to pass through that chicken ID into animal ID. No extra transformations needed. What about for barn type? Remember, this is the large barn view here. So we're going to hardcode that string to large barn. And finally, what about the barn ID? Same as the chicken ID here. We're just going to pass through the large barn ID into a farm animal barn ID. Now before we saw that this function was actually returning a trigger. And why is that? Because this function actually has to replace the insert on the view. Let's take a look at the first line there. Create trigger, and then we have the name of the trigger. And the second line is the meat of it. So instead of inserting in the view, what we're doing is we're going to place that insert, and we're going to run our trigger function for each row that we're inserting into the view. Now, if you want a bit more intuition about what this trigger function is actually doing, I hope that this diagram clarifies it a little bit. Let's start at the very top here. We have the insert into our view. Now, normally without a trigger function, it will go directly to the physical table. But what's happening here is that we're replacing that insert with our trigger function. So for every row that you're inserting into the view, we're going to run that through a trigger function. And then our trigger function actually inserts, after some transformation, it inserts into the underlying physical table, which is the farm animal barn. So this is kind of the intuition about what this trigger function is doing. We can see that the insert now fills our animal type and barn type columns. So in the left side here, we have insert into chicken large barn. And let's take a look at chicken ID 2. It gets passed through, and then chicken ID goes into the animal ID column, and then animal type is automatically hard-coded as chicken. And same with the large barn ID. It gets passed through into barn ID 3 there. And then we can see that the barn type, it was hard-coded to a large barn because that's the name of the, that's the type of the view that we were inserting into. And that's what the trigger function is doing when it transforms our data and then inserts it into the farm animal barn. Now, we only looked at this method for insert, but if you need to do it, you can also use the same method for update and delete, and it will work. So it's very handy. But as you call, if your view is automatically updatable, you do not have to do this. You can just do an insert, update, delete into that view without doing any extra work. You only have to use trigger functions if you want to do some augmentation. And that's why we use the trigger function here, because we actually wanted to do that augmentation. We wanted to fill out those type columns with the specific type of the view. And we saw how, with all these examples, we saw how views can actually easily improve your data model without affecting the underlying tables. Now that we've kind of understood how to use views, I'm going to move on to some useful view parameters. In the beginning, we saw that there's actually a ton of options that you can use when you're creating your view. You can see there some of the options there. We're going to focus on 2 types that would be pretty useful for most people. The first one here with cascaded local check option. This one controls the behavior of automatically updatable views. So if you specify this option, then any insert and update commands on the view, they are first checked to ensure that these new rows that you insert or update, they can be seen through the view. What does this actually mean? So let's take a look. Remember our previous example with chicken and large barn. Let's say we want to insert like a duck in a large barn. If we specify this option, we cannot insert a duck in large barn into our chicken large barn view because it will not be viewable through the view. So this is actually a very handy way of making sure that your view maintains data integrity. And that's very useful because if you're trying to improve the data model, you want some sort of data integrity like this. The second option here is to do with security. So the first type of Boolean we see here is the security barrier Boolean. What this does is it allows the view to provide row level security, and it's very handy if you do need to use that. The second one is also pretty interesting. Security invoker, it's also a Boolean. It checks the base relations against the privileges of the user rather than the view owner. Now, what does this actually mean? So let's say your base table, in our case, the farm animal barn. We have some security checks there that checks against the user. If you invoke this option, then that means these security checks from the base table are also used by the view without any extra work. So it's very handy if you want to make sure that your view has the same security access or same security privilege checks as your underlying relations. And finally, we're going to take a look at views and materialized views. Now, the main difference is that your standard views, they are virtual. They don't store any data. But materialized views are the complete opposite. They are physical, meaning that they store data in your database. They actually have these physical tables. So that means they will have different use cases. So our standard views, the common use cases are maybe simplifying data models like what we've just seen here, and also encapsulating complex queries. But because materialized views are physical, they have very different use cases, usually to improve the performance of read-heavy workloads, or maybe for aggregating and summarizing data for analytics. So if you come across materialized views, I think hope that you now understand the difference between the standard views and materialized views. And after hearing all this, I hope we've accomplished our goal for today, which is to learn about Postgres views and how to use them to improve your data models. We've learned that views are virtual, and then we went through an example case where we created our view. And we can also see that they're automatically updatable. But if you need to, you can use trigger functions to augment the updates. After that, we move on to some useful view parameters that you might want to look into. And we talk very briefly about views versus materialized views. I hope that the next time you come across a complicated or outdated data model, and if you don't have any time or resource to refactor the code, instead of giving up and using it grudgingly, I hope you'll look into Postgres views and see that they can help you improve your data model. Thank you.
As someone new to views, I really appreciated that. I thought the explanation was really approachable, and I came away feeling I can understand views better and how they're used. So thank
I loved
you.
how many specifics he gave too.
So just a reminder again that we really appreciate survey feedback. So please fill in the survey for some of the talks, whatever you can. It's appreciated.
And we also wanted to give a shout out to the Path to CitusCon podcast that Claire and Pino have hosted, I think, for the last year, but there's more than 15 episodes to date. And it's monthly. They're pretty religious about making sure it's at the same time, so you always know when it is. And there's a cool live chat on Discord that happens during it, so you can get this hallway track feel during the podcast. And I've been a guest before. There's a lot of really awesome topics that range from community topics to, sort of self-growth and how I became a developer, and then specific technical Postgres topics. And one of the things that I remember at PGConf EU last year, someone came up to me and was saying, hey, I didn't watch it live, but I caught this episode later. And they were just saying that something that Claire had said in that episode really got them thinking and made their day. And so it's cool because, I'm sure Claire can tell you, when you put a lot of effort into creating content and, working with guests and trying to think of content, as she and Pino have done, like, you don't know whether or not people are actually going to like it, and actually it's worth the time investment. So I thought it was really cool to hear how much of an impact some of the episodes have had on people.
The podcast is being renamed, so this will happen in July. It will now be called Talking Postgres.
I love the new name.
Yeah, it's still the podcast for developers who love Postgres. And I'll just chime in and say I did retire after my 12th episode because I prefer to be usually this kind of thing in front of a camera or a mic. I find it a little stressful, so I prefer to be in the audience.
I fully expect you to be on the Discord chat for every episode going forward.
Yes, you'll see me there. So please join, because the chat is very active. Whether you listen live, please participate, but also just tune in and watch, listen to the podcast. You were a guest on the podcast a few times. And it was just the feel of the podcast is wonderful. It's just so familiar, and then just hearing people's stories. The topics are really great.
There aren't very many other places where you get to hear Postgres contributors and users talking about specific experiences. Like we have a really active blogosphere, and there are some other great, programs out there where people sort of talk about Postgres in a talk radio way, but having the guests, I know there's a few other podcasts now out there, but this one is really special to get to. I know I tuned in to hear about Heikki and Andres's journeys to becoming a Postgres developer, and the benchmarking episode. I thought, I know a lot about benchmarking, but I found myself asking tons of questions in the chat. So it's definitely a good opportunity to feel more connected to the community.
All right, and we'll put up a slide showing. We got the slides out of order, but there should have been a slide there, showing all the great guests we've had. We will mention a few more. All right, so now our next speaker and our last speaker for the day is Varun Dhawan. He's a senior product manager at Microsoft, working on PostgreSQL and Azure Monitor. Prior to Microsoft, Varun worked at Target Corporation and McKinsey & Company, and he worked on observability, DB as a service, and cloud. Varun blogs at data-nerd.blog. And today, he's going to talk to us about what makes Azure Database for PostgreSQL great for developers.
Hey, hi everyone. Welcome to Posette, an event for Postgres 2024. My name is Varun Dhawan. I'm a product manager with Azure Postgres team at Microsoft. Today, I'm going to talk about top features that make Azure Postgres great for developers. I believe this will be an interesting talk for anybody who wants to start developing on Postgres, whether community Postgres or Azure, specifically on Azure Database for Postgres. So thanks for joining in, and let's get started. So my talk today is about what makes Azure Postgres great for developers. Before we get started, a little bit about me. So I've been working on databases, specifically relational databases, for past 20 years. Most recently with Microsoft, but in past I've worked, in Target, as a DevOps engineer, and then I've also worked with McKinsey, in their SRE team. I've particularly worked a lot on SQL, Postgres, and Oracle, and then I have some experience working on NoSQL databases like Influx, Elastic. The key thing is that I love blogging, so I run a blog by the name datanerd.blogs. Do check it out. And then other than that, I heavily contribute, towards a product blog. And these are some of my social handles. You can find me on Twitter, LinkedIn, and also on my GitHub. So today's talk, the agenda is pretty simple. I'm going to give you a very, very 300-foot overview of what exactly is Azure Database for Postgres, which is a flagship service for Azure Postgres. And then we'll dive into, the top features which we believe, makes, which are very developer friendly and, makes job of developer really easy. And then we'll just simply conclude. So let's see, what makes Postgres. Postgres is an awesome relational database. It's built for cloud. It has a lot of awesome things, like extensions, rich indexing, full text search, all the asset compliance, JSON support, now even the vector support. So that's the native Postgres, like right off the box. If you download Postgres, that's what you get. In Azure, we make Postgres, as a managed service. We offer it as a managed service, and we build a 360-degree layer of, the PaaS service around it, starting with security, global reach, ecosystem integration, built-in compliance, intelligent performance, high availability, scale up, scale out features, which is native, to the cloud. Management automation, so that you don't have to do much of the task, like think about backups, high availability, disaster recovery. Like I can go on and on about all the things that DB and the devs have to take care even before they start working on the database. So once you use a managed service like Azure Postgres, you don't have to think about any of those features. The good part is that this is community Postgres. It's not a fork, so which means you get all the goodness of the Postgres right off the box. And on top of it, you can just start developing, for your application. So before we jump into what exactly developers like, let me take you to a little background about we've been running Azure Postgres for many years, and then what are the top use cases that we've seen people using or developers building against for Postgres. So one of those features is web application. The applications which mostly are cloud native or digital native applications, which typically needs very, very high, low latency and fast user experiences. The other class of application is enterprise application. Think about large ERP, CRM, HRMS, kind of solutions, which handle very, very large data sets. Which want to take advantage of parallel queries. They can have unstructured data, so they are joining across data. So those are also a good typical use case. Then GIS kind of system. Think about apps like Lyft or Uber, or wherever you ordered the food next. Like all those applications that rely on the geospatial data. Postgres has this amazing PostGIS instance, extension that brings in the spatial capabilities. So that's another class of applications. Financial services is a very strong, customer base that we see, which is using Postgres, specifically Azure Postgres. Given the 100% the asset compliance of Azure Postgres, it just makes it super ideal, for doing your OLTP type of workloads. And then finally, the newest to join this club is the AI and ML workloads. Like Postgres is at the forefront of the AI revolution, which we are witnessing right now. And given all the native vector capabilities, and then some of the work, which I'm going to show you later in the slide that we have done, Postgres is really a standout database, for applications, which, the AI-ready applications or ML-ready applications. So those are the top use cases. Let's go further. So I'm going to take you the series of, these features with some examples. So let's get started with the first one. So given we are a classic PaaS service, the first thing that we want to offer developers is we want you to focus on the code and not on the ops, which is reduce the ops as much as possible with offering a fully managed Postgres service. So what we see developers doing best or making the best use of time is, that we want you to spend time on designing schemas, writing queries, optimizing your application stack, make sure the performance is okay, make sure, there's no locking, blocking, connection overhead, those kind of things. So that's what we want you to do. And when developers leverage tool like Azure Database for Postgres, as their primary data store, what they get is the ease of management, whereby, okay, well, you don't have to think about a lot of mundane database tasks. Cost optimization, well, you don't have to think about how far you want to order servers, order machine, this is all cloud. You can scale up, scale down, whenever your requirement. Security and compliance comes inbuilt. We have, all the data is encrypted at rest. There is transport level security, which is enabled, and we try to keep up with the industry standards of, the security, whether it's SOX, HIPAA, GLB. Automated maintenance, the database is automatically maintained and patched every month. We let you decide a specific patching window. So all those things come in. Built-in high availability. Even if you don't choose an extra high availability, there is still built-in high availability. However, we recommend you to choose one of the available high availability options, to make sure your database is up most of the time. Peak performance, you can have like tons of parameters to, tweak the performance and make it up to the mark at which you want. There's built-in backup and recovery, which is like most important thing, you want to do with the data. And then finally, there is disaster recovery, and more recently, a geo disaster recovery, whereby you want to protect against the complete regional failures. You can have one region going down, knock on wood, another region can completely take that over. Okay, point number 2 is the familiarity of the dev tools. Now, we want you to work with the tools that you know and love. It's just because like Postgres has been there for very long, and we don't want to take away all the native flexibility or familiarity of the tools that you've been using for very long. So with the Azure Postgres, you have all the native tools which are available. So on the left-hand side, you see the common development tools like Postgres command line, which I personally use a lot. Then there is pgadmin. dbweaver is again one of the favorites. VS Codes, which allows you to bring your application and bring your database all in the single pane of glass. and all the GitHub, goodness, including the GitHub Actions. If you use all those things, this is all available. You can still use it. You can even use things like PG Badger, PG Bouncer, which by the way, it's already built in. All those tools, are natively connect, with Azure Postgres. And then on the right-hand side is the languages, So I picked up, these are the top languages which we see developers using, so be it Java, Python, .NET, and Perl. I particularly love Go a lot, so Go, Ruby, C++. And then we are seeing, these cool new tools like the Superbase, and then specifically Data API Builder, the project that I'm particularly part of, where, these tools offer, connect to your database and convert your database into an API platform. All these tools just natively work with Postgres. Deploy in a snap. Now, the commitment that we offer is to make sure that when you are using Azure Database for Postgres Flexible Server, maximum deployment options are available to you. So you can not only deploy servers fast, but you can also manage your entire fleet in the easiest way possible. So we want to give you a lot of choices doing that. So our entry point, for, Azure as such and Azure Postgres is obviously the portal. It offers the most visual experience for, creating those workloads. You have all the options you can visualize, especially we see customers, visualizing a lot with the estimated cost, the calculator, which you see on the right-hand side. So that's a great place to deploy. But what if now you want to start deploying like tens and hundreds of servers in one particular go? Well, we also have CLI, the command line interface, whereby you can programmatically deploy all those things. You can code them into, your DevOps pipeline, so you can call the CLI command. The thing I want to call out over here is that every single feature which you see is available in the portal, we try to make sure that there is a complementary CLI command or tool also available for it. Well, going further in this journey, we also have Terraform integration, which is like one of the most popular, DevOps tool that you can manage a large fleet of servers, with the Terraform deployments. You can manage your infrastructure as a code. If you want to change any parameter, you want to make sure that it always go through, the complete DevOps pipeline, whether Terraform is the tool for you. And then finally, we have our own Bicep, which is built on top of, the ARM template, So Bicep is a domain-specific language built on top of ARM. And then you can have Terraform kind of deployment, but more native, to the Azure Postgres or Azure ecosystem. Now, let's take the deployment story a little further, and let me show you one more dimension of how it's easier to manage your workloads running, on Azure Postgres. So we see a common place to run your stateless application is Kubernetes. Assuming that you are using, you're already hosting your application on Kubernetes cluster, which is running on Azure, so AKS, Azure Kubernetes Service. Now, we typically see 3 deployment options which are available, and let's study them. So one, which you see on the left-hand side, is the Postgres flexible server instance, which is running on-prem or running on a VM. Now, this is an okay option. You can always run Postgres on a VM. It gives you all the flexibility, except you have to do a lot of plumbing and orchestration in terms of how your application, which is running on, Kubernetes, talk to the Postgres, which is running, on-prem. So there's a lot of coding which we see, which is required, a lot of management which is required. Now, one way to ease the amount of coding and the amount of mundane work is to make sure that you can also have Postgres running on container. Now, Postgres can perfectly run on container as a technology. The only thing is that Postgres is a database, which means it automatically has the data, versus Kubernetes, which is mostly designed for stateless applications. So Kubernetes pod are transient, they fail over, and when they fail over, you have to make sure, that your data and your application is available. So beside that, it still bring you in the common control plane that you can have now your Postgres and your application in the same Kubernetes control plane. However, there are still things that you have to manage, as a developer or as a DBA. But then finally, what if you choose Azure Database for Postgres Flexible Server, which is hosted in the cloud, this can run in the same region, where your Azure Kubernetes workload is hosted. We can have the connections, automatically managed because it's all between the same Azure ecosystem. It can take advantage of network isolations like VNet or private endpoint. And now you do not have to even bother about, any kind of orchestration. All you need to do is just make sure, you're coding against your application, and all the bottom layer is automatically taken care of. Another cool thing, which even I came across very recently, is that we, in the Azure Marketplace, offer something like Azure Solution Ideas. The idea over here is to make sure that when you are building an application, you don't have to bother about, okay, what could be my big stack? Well, I'm developing an internet or mobile-based application, which will be running on Java. Well, I don't know what is the middleware I should be using or what database I should be using. If you go to Azure Marketplace and you search for something like a web app plus database, we automatically suggest, a complete set of the infrastructure tools which will complement, the kind of framework which you're using. So if you take this example from left to right, I'm building a browser or a mobile app. I go in the marketplace suggests me, well, we can build a complete Azure app service for you, which will be connected to your application. Your mobile app will be talking to your app interface using an API, and your APIs, will be talking to Azure database for Postgres Flexible Server, which is the number 4 over here. And, the Postgres over here provides the relational database capabilities with obviously all the relational needs that you want from the database. The key point over here is that you, instead of provisioning and managing these things independently, now in Azure, it gives you flexibility to provision these things and manage them, from a single control plane in one single go, so makes the job really easy when you want to get started. This Azure Solution Idea is a recommended approach. Okay, now a couple of times in my previous slide I've mentioned we want to make it very easy for you to get started. Now this slide is all about getting started easy and still having a big potential as you go up. We want to make sure that the barrier to entry is very easy for developers, and we've think through multiple things to make sure we bring this idea to reality. So I have 4 different things to talk over here. Let's talk with the burstable SKU or burstable instances, what we call at the first place. So burstable SKUs is a standard SKU which is available in Azure. The idea behind burstable SKU is that when you are developing an application, there are times when you don't really know how your workload is going to be look like. It's your application is just new application. You're experimenting with an idea. You still want to make sure, when your application is running and if there is a spike in the load, you still want to be sure, that it's able to service it, but you are very conscious with the cost. Well, burstable SKUs are an option for you, whereby they make sure that when you have a specific CPU and memory capacity allocated, and if you're not using that capacity, you earn the credits towards not or use capacity. And then eventually, when there is a spike of the load and you want to use the CPU, you want to use this memory and IO, then it's just going to burst. It's just going to use those credits. It's not going to really bill you for that. So it's a very good option, save you tons of money, to get started with the burstable SKU. The other thing is start-stop, database instance. Well, it's a no-brainer. Running applications in the cloud, irrespective whether they're using it or not using it, will still incur a billing. We went ahead and we added this feature, which is start-stop instances, to make sure for most of the workloads, let's say your dev and test kind of a workloads, you don't want them to be up and online, 24/7 or working them over the weekends. But at the same time, we don't want you to destroy those instances and start them from the scratch, when you join, when you want them. With the start-stop instances, you can stop instances kind of, for the duration for you want, and then you can restart them whenever you're ready to use them again. The key thing is that the duration for which your instances are stored, we won't bill you for your compute, we won't bill you for your storage. Then there is reserved instances, or reserved instances is again an Azure specific offering, which is also available for Azure database for Postgres. Like typically you will go and you will purchase some kind of compute capacity on a pay-as-you-go model. Well, you need more, you provision more instances. If you do a little budgeting and you reserve some capacity in advance, what we have seen is that with the reservations done for 1 year up to 3 years, people can save up to 60% on the cloud compute costs. So reserve instances is a great way also to save costs on your cloud bill. And then finally, my favorite is the free trial. Well, everyone loves free stuff. We give a 12-month free trial, with Azure free account. So all you do is, go to, azure.com and just search for Azure free service for Postgres. You will have a homepage like this where you can just claim, your free account. And then I see, you get 750 hours of, the free service. You get 32 GB of, your database storage. In addition, you get 32 GB of your backup storage. And you just don't have the Azure database for Postgres, but you have many other services, which are available for free. So I'll highly recommend to use the Azure, free account for exploring some of these options. Performance. Well, as a developer, we always want to make sure, that the code we develop is working with the highest, performant level. We want to make sure, your application is always working with the least latency and the users are able to, get their work done always. Now, we typically as a PaaS service, one of the way we run, any kind of PaaS services to make sure we abstract, all kind of routine activities and routine management of databases from you. But then in Azure Postgres for Flexible Server, obviously, as the name suggests, we want to keep it a little flexible and offer back many controls to you. So let's see, how do we offer these controls back? So one way is allowing you the maximum control of your databases in terms of the server parameters. We allow, approximately more than 100 plus parameters which are configurable. Rest, all the parameters are available for you to read only, so you can see all those values. You can configure CPU, which is the native elasticity of the cloud. You can, scale up, scale down, and you can scale these things independently, CPU storage, CPU memory and storage, or you can scale them, together. The maintenance is configurable, so you can decide which day of the week you want to do maintenance. So that's an option. And then you can configure, other things like network, whether you want to do with the VNet isolation, whether you want to, enable private endpoint, to secure your instance. The other way is the tune performance. Like, you always want to make sure when you're developing against, your application, how is your production workload performing? How is your query performing? So we have this functionality or a feature called Query Store, which automatically, maintains the history of all the queries, which are being executed against the database. And then we allow you, and you can go and you can query the views in the Query Store, and you can do a lot of top-end analysis and find out, why something has been running low, why something, which are the queries which are running, with the highest duration. You can look into, their explain plan and find all those things. There are people or developers who say, well, we want more visually, appealing dashboards to quickly be able to tell which is like my, top performing query, do any kind of top-end analysis. Well, we have a feature called Query Performance Insight, which is actually built on top of Query Store. And then these has a very beautiful visual dashboard that you can do for doing top-end analysis, top CPU, top memory, top MP usage. And then finally, we have intelligent performance, by which you can automatically tweak, auto vacuum and writes, for your database. And then maximum observability and monitoring. The saying is, if you can monitor something, you can improve it. We offer 70 plus monitoring matrix. There is logs available, so the logs are by default integrated with Azure Log Analytics. So you have powerful KQL and custom queries that you can run, do all kind of trendings with your logs. Or you can, most recent feature is that you can now download server logs. These are text files, as if like you are downloading the Postgres logs. You can run them against popular tools like pgvector or do any kind of analysis with the logs. Finally, we have a seamless integration with Grafana, which is the most popular open source visualization tool, with the Azure Monitor plugin. So each of the 70 metrics that I talked about is, you can just visualize them in the Grafana. Connection management. Now, Postgres by design, has some opportunities, when it comes to the connection management. So if you see the diagram on the left, what happens is when your application make connection, to databases, with every connection, there is a little bit of a memory which gets consumed. Now, if the application is not doing a very good job of closing the connections, then the chances are that this memory resource goes wasted, and this could have been used for caching your data and making your application run faster. So typical recommendation is to use any kind of a connection pooler in between your application and the database. Now, Azure Database for Postgres, again, to make the job of developer easy, offers a built-in connection pooler, which is PG Bouncer. So PG Bouncers now just come built in. All you have to do is just enable the toggle, just turn it off or turn it on. We have the latest version of PG Bouncer. When you enable PG Bouncer, all you need to do is, instead of connecting to default port, which by the way is still available for connection 5432, all you do is start connecting to port 6432. And then you can also access, the PG Bouncer admin console if you want to be more geeky about it and want to see how is the connection management happening. Or we have PG Bouncer Matrix for you to monitor, the connections. Extensibility. What really makes Postgres different from other databases, is the extensibility. It's like extensibility is the functionality, or it's the features that enhance your database with the powerful extension, which are tailor-made for your need. So let's let's understand what are the extensions. So extensions, are these feature functionalities, which extend the Postgres beyond your, core database engine. You can load new set of functions, like new data types, new indexes, new operators. In the Azure Database for Postgres Flexible Server, we offer more than 60 plus third-party extensions, like the popular ones being pgvector, timescale DB, PG Audit, which is very, very useful for auditing, PG Start Statement, which is very similar to the query store. You can enable and disable these extensions using Portal or CLI. And then most recently, we have offered this, new feature by which you can actually upgrade the extension to their latest available version in Postgres. So it's very easy, to manage extensions, and you can use most of these extensions, which we have, to offer today. And then finally, we cannot go without talking, AI, which is like the big, revolution which is happening in the industry right now. Now, Postgres is at the forefront of this AI revolution when it comes to the database. Why? Because Postgres automatically comes with the support for, the vector data types. Now, there are a couple of things first we have to understand in terms of how is Postgres more well-positioned or the most well-positioned database to, for the AI kind of workloads. So first of all, I mentioned, Postgres supports the vector data types with the help of this pgvector extension. It's an open source extension, which is gaining insane popularity in last 1 or 2 years. We offer the version 6.1. What vector data types allows you to do is that it allows you to natively store the vector embedding in your relational tables, just along side by side with your data. And once you're able to store this data, then you can do any kind of querying on the data. And there is indexing which is available, like HNSW, IVF flat, by which you can query this data. And then once you have the queryable data stored as embedding, then you can run any kind of similarity searches. You can do natural language querying with this. Now, there's one problem with the vector extension is that once you store the data, when these embeddings are stored, but then you want to have them talk to any kind of large language models like OpenAI or Hugging Face or Llama. In that particular case, you have to write a lot of code to make that integration happen. Our team has been hard at work, to make sure that we bring AI capabilities at the forefront. So we launched, this Azure AI extension last year, which offers a very easy SQL interface to talk to, large language model like OpenAI. You can create embeddings. You have a native SQL interface, to query those embeddings, and it just completely, it's just complementary to pgvector. So let's see this with a quick example. So let's say I have a recipe database, which is like, think of us as being a restaurant. I have tons of recipes over there. And then, in the recipe database, you see, I don't have a column. I just want to make sure that how can with the natural language querying, I can query, data in the recipe database. So if I create the Azure AI extension, all I need to do is, create the extension, provide it with an endpoint and API key so that I can securely communicate, to my large language model. And then I can run an update, on my table, 1 row or 1 million rows, and make sure in this particular case, the product description, I want to make sure that I, vectorize this particular data. Once I vectorize this data, it talks to the large language model, in this particular case, OpenAPI, and returns all the vectorized values, for me. And once these vectorized values are returned, they are stored side by side along with the product. So I have the column number 3, which is product description, and then my last column 5, which is actually the vectorized product embedding, which is there. So once I have this kind of a data, what I can do is, if you see, follow me from left to right, I have an application which is trying to make a natural language query call. So somebody's searching for, okay, well, in your recipe database, just return me all the high protein recipes, So this kind of queries goes to the database. Database in terms is going to make an API call, to the large language model, OpenAI in this particular case. OpenAI is going to return a lot of vectorized value back. And remember, these vectorized values which are returned back we can calculate some kind of similarity distance between the vectors which is stored inside our database. And that finally is returned to the user. So in this particular case, for a high protein recipe, I can see, it's returning me, something about chicken, it's returning oatmeal and salad. Now, none of these recipes actually have high protein embedded in it. It's just the large language model, doing the AI similarity search, and this it automatically knows, that each of these recipes and these ingredients are high in. So that's an example of, how easy it is and how out of the box it is for developers, to build an AI kind of an application with the Azure database for Postgres. So besides, once you have the vectoring capabilities in Azure OpenAI extension, it's not only the similarity search, but you can also do, you can also take, advantage of, the language search. You can call all the Azure cognitive services, things like machine learning, storage, AI services, and you can build all this new generation of application with Azure database for Postgres. So let's do a quick repack. We kind of, went through 8 very quick things. Sorry if I was being fast, but high level, we want to make sure that you focus on the code, less on the operations. You use familiar dev tools. You can deploy, very fast. You can start easy and then grow as you go. Performance, we give you a lot of controls. We give you a lot of, feature, configurability back to you. There is a built-in PG bouncer to help with the connection pooling. You can extend database functionality with all the awesome extension that Postgres has to offer. And then finally, it's AI ready with the pgvector extension and Azure AI extension. These are some set of resources which are available for you, especially, the blog, and then especially, our docs. And we try to, make sure the team is always hard at the work to make sure all the new good things and the features month on month are always available and documented for you. So I'll urge you to check those out. With that, I want to thank you again for staying with me for the duration of this talk. Hope you have something to learn about this and which you can take away, once you're developing. And just good to have you here, and enjoy the rest of your Posette conference. Thank you. Thanks again. Bye-bye.
Varun, thank you for your talk. It was great to see the array of features. Sorry, go ahead.
Oh, I was just going to say, and you're so active in the chat answering everything that came up.
Yeah. It was so great to see all the array of features that Azure PostgreSQL offers customers, so that they can just focus on developing. So yeah, again, thank you. And now, so a reminder about feedback, and we're going to do a wrap up. We have about a little bit less than 10 minutes of announcements, so please stick around if you can. Wanted to let you know what happens next. You can attend live stream 4. I think it's in about 9 hours. It's at 8 a.m. Central European summertime. Please join Discord, give us feedback. We already talked about that. And you can replay the live streams. Very soon after this finishes, you'll see the live stream 3. So for anyone who missed parts of it, it'll pop up. You can always already find live streams 1, 2, and 3 are already playable. Not the individual talks, but the whole live streams are already online. And then you can find our schedule page and our playlist here. I think the Posette playlist is probably still pointing to CITESCon 2023, but I might be wrong. But after the event, go to aka.ms/Posette-playlist, and you'll find all of our talks. This is a little preview of what we're going to see in 9 hours or so. Did we talk about this already, Melanie?
I don't think we really went into any of the details. So I guess
we saw a preview.
Oh, we saw the trailer.
Earlier.
Yeah, we did see the trailer.
Did you want to add anything about what?
No. I mean, I'll be asleep during this, as we talked about in the chat. But I'm super excited. My team member Thomas Monroe was telling me about some of the content that was going to be in his keynote. So that's one of the ones that I've had a sneak peek of, and it's a lot of fun. So I'm excited to also watch and replay all the other talks as well.
Okay. All right. Thank you. We talked a little bit earlier about the podcast Path to CITESCon, which is being renamed Talking Postgres. I didn't get a chance earlier to show all the great guests we've had so far in 15 episodes, and there are some faces here you've seen in this conference, as well as others. Just a lot of great folks that really brought their all and told great stories during the podcast. And next week, a week from today actually, is episode 16, the making of Posette. The making of this conference. So Teresa Giacomini and Aaron Wislang will be on the podcast with Claire Giordano, the podcast host, and we'll hear all about what does it take to make a podcast a conference like this one, and all the collaboration that came into this, because it's a community. It was a community collaboration. So please tune in for that.
Yeah. And that there are lots of upcoming Postgres community events. I helped plan my first, major Postgres community event earlier this year. And just thinking about what's going to be on the podcast episode next week, I can tell you that so much more goes into it than you think about as an attendee. There's so much behind the scenes. Like right now, we're literally talking about, okay, we need to use the project management software because this isn't going that well. We don't like task assignment, all this stuff. So I'm excited to hear what secrets the Posette team has for how smoothly everything went. But all of these other Postgres community events that are coming up, there's Swiss PG Day. So one of the great things about PG Day is it's one day. So especially if you live nearby and have access to go, you can sort of only have to take one day off of work and hear a lot of great Postgres content. So that's coming up at the end of this month. And then there's PG Day UK, which I just saw Dave Page posted on the Postgres social Telegram channel. That registration is now open for that in September. And PG Day Lowlands is just 2 days after that. I think a lot of times they plan PG days in cities that are relatively nearby each other a day apart. So those of you who do travel and are not local to where the PG day is can make it to both of them, which I think is super cool. I've never gotten to do that. I know there's, what is the other PG day combo? PG Day Nordic and Paris, I think, are usually like that.
I've heard about that too.
Yeah, so I didn't realize that. I hadn't heard of PG Day Lowlands until now, so that looks cool. And it looks, you can see here, the CFP is going to open soon for PG Day Lowlands. So have to take a look and see who's going to that. And then PG Ibiza is in September. It looks like it's kind of overlapping with those two. So if you're in Spain and you want to go attend a conference that's in a lovely island destination. I haven't been, but I hear it's lovely. That's happening. And the CFP for that will close at the end of this month, or not quite the end, just June 23rd. And then there's PG Conf NYC and PG Conf EU. PG Conf NYC, I usually make it. I live in Philadelphia, so I'm like an hour and a half, 2 hours from New York. So I definitely always try to make it. It's a great opportunity to interact with users. If you're a developer. It's, you know, there's so many users that go to it, and it's just very well run and really exciting to see, you know, that demographic of users that are, you know, a lot of them are in finance and doing like sort of super exciting things with Postgres. So that's pretty cool. And I love the venue. It's in Convene, and I constantly rave about how amazing it is, because it's the perfect space for, you know, you sit down and the hallway track, you can like get together with someone and have it's sort of a hub and spoke like format. So the rooms all come off of this central area, and it feels like you're in a cozy library with your friends talking about Postgres. So definitely recommend that. And then EU is in Greece this year, which is super exciting. PGConf EU. That last year I went to my first EU. Have you been before to PGConf EU, Pino?
I have not been to PGConf EU yet. Yeah, but a bunch of our colleagues went and had a great time.
Yeah, it was amazing.
A lot of people, yeah.
So yeah, so many people. Like I guess I haven't, since I've been in tech, I've really I've mostly gone to Postgres conferences, one occasionally to All Things Open, but this was the biggest Postgres conference that I'd seen, and I was like, oh my gosh, how do they coordinate this? How do they do this? There's just, you sit down at a table and you meet someone who's like, oh, I work for the, you know, defense department of this country doing stuff with Postgres that I can't tell you about. And you're like, oh, that's interesting. And then you sit down at the next table and it's someone using it for maritime exploration or whatever. It's just like very cool. So yeah, that's the FP.
And it's nice to see such what a lineup of events in what, the span of 4 months.
Yeah.
Yep.
Yeah. And all of these are coordinated by volunteers in the community. So I guess I will say, if you are interested in volunteering, I'm sure any of these events would be happy to have your help.
Yes. Please volunteer.
So yeah, looking for more great content. Exactly. So CitusCon has been going on for 2 years before it was renamed to Posette. So you can go and see the playlist from 2022 and 2023. I know I've gone back and listened to many of those. I don't know about you, Pino, but I'm a big YouTube in the background person. Yeah. And thank you to our speakers. So it's really hard making content that's good. And so obviously this program wouldn't exist without speakers. So we're super, super grateful to speakers for taking the time to make such good content.
Yeah, really, thank you again. We can't say it enough. And then the fact that these videos are available for the community to watch, and they're very high quality. And it's a little bit awkward for the speakers, you know, not always being in front of a live audience, depending on how it's recorded. And the conference is a bit of a different format, so we appreciate the flexibility that the speakers have in running the show this way, and then showing up and dedicating all their time to come to the live stream and answer questions. Thank you all so much.
Yeah. And we're also really grateful to the organizing team. And Teresa has done so much to make this event happen. And Aaron and Ari and Aaron have done so much as well. So we're just really grateful to them and for making this event happen.
I'll say, at least, you know, I as a co-host, I mean, just incredible how easy they made it for me to show up and be a co-host on the show. The materials that were given to me to help me prep, it was all there. And it was really, you know, I could see that all of that preparation that went behind it, so that I could so it made it easy for me, at least.
Yes, I will tell you guys a secret. Pino and I did not make these slides. We copy pasted a few of them into the order that we wanted to use, but like the super pro-ness of all of this was totally
this great team. So thank you all.
Well, I think that's basically it. We were fast. We got that done quickly.
Yep. So we kept our promise that it would be under 10 minutes. And thank you to the audience. You make the event special. You make the event worth doing for our speakers, for everyone, for the organizers. So thank you for watching and for attending.
And we'll see you all in live stream 4.
Yeah, see you all in live stream 4.